Okay, so to start, let's recall um, some ideas from last lecture. We are looking at a sequence of real numbers. No? Okay, we will say that this infinite series of numbers are usually written in this manner. No, converges to some number s if and only if ang ating condition is that the sequence s sub n converges to s. Where ano yung s sub n? Ang S sub n is the nth partial sum. So by a partial sum, we actually mean the sum of the first n terms. Okay? So basically, kapag sinabing sum ng isang infinite series, first of all, bago ka magkaroon ng sum, hindi ka pwede magkaroon ng sum kung hindi ka nagko-converge. Okay? So to converge means kailangan yung sequence of partial sums mo ay nagko-converge. So when we're talking about infinite series, we're not really actually adding the numbers all in all. What we are doing is we are taking partial sums little by little and then observe the partial sums if that partial sum has a limit. Kung saan man nagko-converge yung sequence of partial sums na ito, then that limit is what we call as the sum. So in this case, again, the sum is not actually something that we have obtained from doing a finite number of operations. No, it is usually obtained by taking limits. So let's go back to our slide and let's consider this example. Um, let us say that you are adding, or let us say that you are considering the infinite series as shown on the blackboard. No? So first of all, yung first term yan was obtained by letting n be 1. No? When n is 1, ito siya. When n is 2, ito siya. N is 3, ito siya. Okay? So, first, kapag nakakakita kayo ng ganyang sum, ay ng infinite series, you don't think of the sum first, no? Ang una niyong iniisip dapat, if it is even uh, convergent, no? Kasi bago ka magkaroon ng sum, dapat convergent muna. How would you know that it is convergent? Well, you look at the sequence of partial sums. So, for example, the partial sum of this infinite series is S sub n, and it is given as shown. Ito yung first term, second term, ito yung nth term. Yung nth term na yun, nakuha ko yun from the formula. Okay? Now, we will look at this partial sums kung ito man ay ever nagko-converge. How would you know? You wouldn't know at this form kasi meron kang dot dot dot. So, sabihin it's written in, well, in a not so nice way. But somehow, we can make use of the following identity. Anong identity yon? Yung 1 over k times k plus 1, kapag meron kang integer na k, can actually be uh, decomposed as a sum of two fractions like this. Yung mga partial fraction decomposition na tinatawag niyan. No? You can actually decompose this expression as shown. No? You can verify no by simply subtracting once again. So kapag meron kang 2 over k times k plus 1, it is actually 2 over k minus 2 all over k plus 1. Correct? Alright. Now, paano natin gagamitin yan? So for example, yung 2 over 1 times 2 pala is basically 2 over 1 minus 2 over 2. Okay? Halimbawa, yung 2 over 2 times 3 is basically 2 over 2 minus 2 over 3. Right? And so on. So, decomposing each one or each expression as sequence of partial fraction, we observe some nice thing. happening, no? Kapag dinicompose mo yun mga ito into partial fractions, you will get something like this, something like this, something like this. And now because this sum is finite, lahat ng mga rules ng algebra still nag-a-apply. Ano yung ibig sabihin ni Sir doon? You can still use commutative property, associative property, or whatever. And you will find that these terms cancel. Ito, magka-cancel yan doon sa susunod. Hindi ko lang pinahaba. But, ano ba, gawin natin yung pangatlo. Yung pangatlong term ay, sige, insert natin dito, ha? Yung pangatlong term ay 2/3 minus 2/4, di ba? Ayan, magka-cancel siya dito. Ito magka-cancel doon. Ito, eventually magka-cancel hanggang doon. In the end, we are left with something like 2 minus 2 over n plus 1. Ang naiwanan dito, yung dalawang nasa dulo. No, ito yung 2, ito yung minus 2 all over n plus 1. At by expressing this sum, no, in this manner, you can observe the limit easily, no? As you let n approach infinity, you know very well that this is approaching 0. So therefore, S of n converges to 2. Ayan, may sinasabi may nag-PM, sabi niya, telescoping series po ba yan? Yes, yan yata yung terminology na ginagamit, telescoping. But I don't really get why it's called telescoping up until now. So I don't really use the term. But yeah, nababasa ko yung term na telescoping series. Correct. So therefore, we verified that the sequence of partial sums S of n converges to 2. And we can now declare that this series converges and this series equals 2. Kapag ang limit ay 2, hindi natin ginagamit yung ganon, di ba? Ang ginagamit natin equality to denote that we are actually parang nag-a-add talaga tayo. Well, in fact, hindi naman. We really just did a limiting process. Okay? Naintindihan yung example natin, yung unang example natin for the day. Before I continue. Okay. So let's take another example. Yeah, ito'y sikat na example, yung series na 1 minus 1 plus 1 minus 1 plus 1 minus 1. So it just keeps on repeating kasi itong sequence na to will just oscillate between 1 and -1 as n proceeds, no? So we are asked then what is the sum of this? What is your idea? What is your idea about the sum? Ito yung danger ng maling pagtatanong, no? Actually, yung question dito sa example na to is wrongly asked, no? Kasi you are asking about the sum. So meaning to say you are assuming convergence. You did not even consider that it might diverge, no? Pag nagtanong ka na what is the sum, baka kung yung tatanungin mo baka magbigay na ng mga opinion. For example, one opinion could be zero yan sir kasi pwede kong i-group itong mga to, no? I will just get 0 plus 0 plus 0 plus 0. Yung iba naman magbibigay ng opinion, hindi sir, 1 ang sagot kasi I can regroup these things. Right? So I have 1 plus 0 plus 0 plus 0 plus 0. Some other opinion will tell us that, sir, yung sum ay 1/2. No? Nakakita na rin ako ng argument na 1/2 daw yan. Kasi kung tatawagin daw na S ito, tatawagin na S daw yan, okay, mag-subtract ka ng 1, tanggalin mo yung first term, okay, ito yung matitira, no? Tapos, multiply ka ng -1 on both sides, you get something like this, and then you get like that. Pag multiply ka ng -1 on each term, what you find out is that yung right-hand side is already the same sum as before. So you get the following relationship. Tapos, mag-add ka ng s on both sides. 2s is 1, therefore s is 1 half. No? So ano ba talaga? Is the sum equal to 0? Is the sum equal to 1? Or is the sum equal to 1 half? The truth is none of this is true. They are just opinions. Kasi in the first place, the question is wrongly asked. Ito yung sinasabi ni sir. You don't, when you see an infinite series, you don't ask right away what is the sum. No, that's crazy. No, that's stupid. Kasi you did not even check kung meron mang sum. Kasi the word sum here, kapag sinabi what is the sum, you are assuming that there is a sum. You are assuming that there is a limit. No? When in fact, in this example, there is none. No? So, to see that there is none, you see that the n partial sum, but may s to, is given as follows. No? Tingnan nyo. When you look at the first term, no, this is s sub 1. S sub 2 is this. S sub 3 is the sum of the first three. What do you notice about S sub 1, S sub 2, S sub 3? When n is 1, that's 1, 0, 1, 0. So, there's a pattern. No? The pattern is that S sub n is 1 if n is odd, and S sub n is 0 if n is even. You see that? No? You know very well from convergence of sequences, you know that this sequence diverges. Kasi it's frequently 1 and it's frequently 0. In fact, yung 0, you call it the limit inferior at yung 1 ay yung limit superior. Kumbaga, ang sabihin ng limit inferior, siya yung pinakamaliit na limit point. Ang limit point ay limit ng isang subsequence, not necessarily ng buong sequence. If you consider the odd terms will converge to 1, the even terms will converge to 0. Therefore, 0 and 1 are limit points, but they are not limits. Ang tawag mo sa pinakamaliit na limit points, you call it the limit inferior. Yung pinakamalaking limit point, you call it the limit superior. And because these two things are not the same, that is a proof that the sequence diverges. Kaya, wag yung tatanungin kung ano yung sum ng infinite series na to because it has no sum. No? So lahat ng mga pinakita natin mga arguments kanina are all wrong kasi they are all assuming that there is a sum when there is none. Did you understand the moral of the story? The moral in this example? So the next time that you see an infinite series, you don't ask right away what is the sum. That's stupid. Okay? Huwag kayong maging stupid. Okay? Naintindihan ninyo? Ang tatanungin una kapag nakakita ng infinite series, hindi naman finite sum kasi ito. No? Kapag infinite series, you ask first whether there is really a sum or is the sum even convergent. Okay? Ang isa pa sa mga pinakasikat na infinite series out there ay yung mga geometric series because they behave well, no? Here, A and R are real numbers and to be geometric, dapat yung R ay hindi 1. Ang nangyayari, you start with some number A, then the next term will be produced by multiplying the same constant R, no, which is not 1. Kasi kapag ang R ay 1, A lang yan. Okay? And that's not even geometric. Correct? So, ang R bawal maging 1. Okay? So, A plus AR squared plus and so on. Ito yung mga terms nung tinatawag nating infinite geometric series. Now, here A and R are unknown. They are just given. No? Ang tanong dito, when does this converge? Kailan nagko-converge ito? Anong conditions about A or R ang meron so that this series is convergent? Well, if you look at the partial sums of this infinite series, this is the first term, the second term, the third term, the last term, the nth term. Okay? You can factor out A, lahat ng mga ginagawa niyo sa algebra, pwede if you're working with the partial sums. Kasi finite sum yan. Now, ano nangyari dito? Ba't nagkaroon ng ganon? Well, I used the following identity from algebra. If you multiply 1 minus r with 1 plus r plus r squared plus r to the n minus 1, what you will be obtaining after multiplying is 1 minus r to the n. And because r is not 1, that's why this is important, yung 1 plus r squared and so on hanggang n minus 1 will be 1 minus r to the n all over 1 minus r. So therefore, this sum reduces to the following expression. So therefore, yung convergence ng infinite series na to ay nakasalalay sa convergence ng expression na to. But again, sino ba yung variable dito? The variable is n. Si n yung gumagalaw. A is not moving at all. R is not moving at all. The one that is moving, has a moving value is n. So therefore, when you look at the expression, si r to the n ang magsasabi kailan siya mag-converge, no? But from what you know, kailan ba nagko-converge ang nth power ng r, no? Kailan ito nagkakaroon ng limit, yung r to the n? Diba, ito bang 2 to the n may limit? How about 1/2 to the n? No? Diba ito may limit, nag-0, pero ito nagda-diverge sa infinity. Ang tanong, for what values of r is the power r to the n convergent? Sino nakakaalam? For what values of r nagkakaroon ng limit ang r to the n? Ayan, sabi ng PM, r is between 0 and 1. Correct, nagko-converge if r is between 0 and 1. Pero pwede rin naman ang r0, di ba? Kapag ang r0, you get what? You get 0 all the time, so constant. Actually, pwede ring negative yung value ng r. Wala naman nagre-restrict na bawal mag-negative ang r. Kaya lang kung negative, bawal siyang umabot ng negative 1. Yeah, correct. So the proper interval, no, magko-converge ka if r is between strictly negative 1 and 1. Okay? Or in other words, no, sometimes we write this by writing the absolute value of r is less than 1. Pag nakikita nyo yan, sabihin yan yung r nasa gitna ng negative 1 at 1. Kaya nga nagko-converge yung nth partial sum natin if and only if the common ratio r has an absolute value less than 1. So common negative 2/3 si r, pwede yun. Si r ay negative 0.99, okay yun. Wag lang siya aabot ng negative 1, no? Right. So, in this case, alam na natin yung condition. Ito yung condition that we need to guarantee convergence. Now, if the absolute value of r is less than 1, what do you think is the sum? What do you think is the sum? If r has an absolute value less than 1, you know that r to the n simply converges to 0 kasi si r ay maliit. Kaya yung n power niya papaliit ng papaliit. Kaya when you look at this expression, if r to the n converges to 0, ang may iwanan ay a over 1 minus r. Okay? Kaya ang tatandaan ninyo, if r has an absolute value less than 1, meron tayong formula para sa sum ng isang infinite geometric series. The formula is for the sum is a all over 1 minus r. Ano yung a? Si a yung first term. Si r yung common ratio. Did you understand? Yun nga, ang tawag natin dyan ay infinite geometric series. This is already something that you know, no? Now, when you look at our examples so far, no? Para akong nagbibigay sa inyo ng pag-asa Parang ako nagbibigay sa inyo ng fantasy na lahat ng infinite series malalaman natin yung sum, no? Basta nagko-converge, correct? It seems like binibigyan ko kayo ng binibigyan ko kayo ng pag-asa na basta nagko-converge ang isang infinite series, the sum can always be obtained. The truth of the matter is no. 99% of our examples, no? Mapapatunayan natin na sila ay nagko-converge pero it's not all the time madaling hanapin yung actual sum. The truth is my examples in the previous slides, no, are carefully chosen so that the sum can be obtained, no? Para syempre start pa lang ng discussion, so parang feel good muna, 'di ba? Ganyan ang discussion. But in general, normally or under normal circumstances, not because you were able to show that the series is convergent to a sum, it doesn't mean that we can actually get the value of the sum. Parang ano yan eh, not because you have shown that the sequence has a limit, it doesn't mean that you can obtain the value for the limit. Some limits are very hard to actually get the value or the exact value. Sometimes we can approximate, no? But sometimes we can just base our yeah we can base our what they call this, we can just base everything in terms of trust, no? Parang maniniwala na lang tayo na nagko-converge siya kasi may proof tayo sa isang number, pero kung ano yung limit, we actually don't know. In fact, for most of the times, ganun yung nangyayari. But before continuing, let me just state the following. If you have two convergent series, summation AN, summation BN. Pag tinatamad si sir, ganito na lang yung infinite series natin, ha? Okay. Then the following series are convergent. Yung unang series is obtained by adding the two series term by term. Ang tawag dito ay term by term addition. Ibig sabihin yung first term ni AN, inad sa first term ni BN, and so on. Excuse me. Ito naman, term-wise multiplication by a constant R. Lahat ng term multiply by R. Convergent din daw itong dalawa. In fact, we were able to point out kung anong sum nila. Yung sum nung term-wise sum ng AN at BM is just the sum of the individual sums of the two series. Okay? Kung meron ka namang R dyan sa loob, you can bring that out just like for finite sums. Hindi naman ito nakakabigla kasi ito'y properties ng mga finite sums. In this theorem, it tells you that as long as your series, the series that are involved are convergent, you should not be scared or afraid to use these properties because they still hold. As long as you know that the given series are both convergent. So, all right. So, why is this correct? Or why is this so? So, let's assume that sabi nyo kasi ito yung nagko-converge. So, kunwari ito ay S. Kunwari yung sum naman ng mga BN ay T. So, assumption yan. Okay? Yeah. So, ang makakapagsabi kasi kung nagko-converge or nagda-diverge yan ay ano, di ba, yung what do you call this? Yung sequence of partial sums. So, pakalanan natin yung sequence of partial sums. Kunwari, Sn para dun sa summation An, tas Tn para dun sa summation Bn. Be the sequence of partial sums for summation An and summation Bn respectively. Okay? Then what do we know about Sn and Tn? Si S sub n nagko-converge kay S, si T sub n nagko-converge kay T kasi given na yun yung sum, no? Now, if let's say U sub n is the sequence of partial sums of, let's say, yung summation AN plus BN, kunwari yun yung sequence of partial sums, So, paano magko-converge? Kailangan yung UN mag-converge, no? Anong itsura ng UN? Ganito itsura ng UN. Ang UN, ang first term niya, A1 plus B1. Di ba? Tapos, ang second term niya, A2 plus B2. Di ba? Plus and so on. Ang n term, AN plus BN. Like so. Yan. So, because the sum is finite, the series is finite in this case, you can apply the rules of algebra. In other words, I can collect all the A's together and I can collect all the B's together side by side like so. Now, the sum of A1 up to AN, that is the n partial sum S sub n. Diba? Tapos yung sum ng mga B sub I together side by side, yun yung T sub n. So, what we have obtained is that U sub n is basically the sum of the convergent sequences S sub n and T sub n. From calculus, we know that the limit of U sub n, if it is a sum of two convergent sequences, must be convergent. It's the limit of S sub n plus the limit of T sub n. So the sum is S plus T. So therefore, from here, what can we obtain? From here, we can say, from here, we can say that the infinite series summation an plus bn is convergent and its sum is what? At ang sum niya ay S plus T. Diba? Yun yung limit kasi ng sequence of partial sums niya. S plus T. But what is S? Yun yung sum ni A. Si T siya naman yung sum ni B. Okay? And that completes the proof for the first case. Itong part na ito, I will be leaving that to you as an exercise. May tanong kayo tungkol dito? May tanong kayo tungkol dito? Okay, none. So for example, show that the following infinite series converges. And luckily, no, in this example, we can actually obtain the sum. Sige nga, how would we show that this infinite series converges? Well, at first, it looks overwhelming. Huwag kayo ma-overwhelm pag nakakita kayo ng complicated expressions. Like so, no? Gusto nyo, look away first, no? Kung kayo'y kinakabahan doon sa itsura niya, look away muna. Balikan nyo ulit. Titigan nyo hanggang masana yung mata nyo sa itsura niya. And then, may papasok sa isip nyo. Basically, ano lang pala to, dalawang terms divided by a single term. So maybe I can divide, no? Note that yung 3 times 2 to the n plus 2 times 3 to the n divided by 5 to the n is basically 3 times 2 to the n over 5 to the n, that's 2/5 to the n. Yung 3 to the n over 5 to the n, that is 3/5 to the power of n. So basically, it's a linear combination of two powers. No? Interestingly, yung mga powers na ito are powers of numbers whose magnitude is less than 1. Yung 2/5 less than 1. Yung 3/5 less than 1. Diba? So what do we know? Since the sum of 2/5 raised to n mula 1 to infinity is convergent, sama na natin yung isa. Are convergent. Why are they convergent? Anong reason? What is the reason why they are convergent? Excuse me. What is the reason why are they convergent? Uy, bakit sila convergent? Anong uri ng series yan? May pangalan yan eh. Why are they convergent? Ano sila? G. Yeah, they are geometric with ratios. Geometric ang ratios ay less than 1 ang absolute value. Kagaya dito, ang R dito ay 2/5. Ang R dito ay 3/5. Parehas ang absolute value niyan, less than 1. So, nagko-converge. Dahil sila ay convergent, dahil geometric, so yung linear combination nila na yan, convergent by the previous theorem. Di ba? Mag-add ka or maglagay ka ng constant sa tabi, hindi nagbabago ang convergence. Therefore, the sum 3 times 2/5 to the n plus 2 times 3/5 to the n is convergent. In fact, anong sum nila? Anong sum yan? Sige, gawin natin yung sum. Ang sum niyan ngayon is basically 3 times the sum of this infinite geometric series plus 2 times the sum of this infinite geometric series, 3/5 to the n. Like so. Going back here. Ano ba yung sum ng infinite geometric series na to? Geometric yan eh. Anong first term yung series na ito? What's the first term? Yung formula A over 1 minus R. Okay? A is the first term, R is the common ratio. So what's the first term of this series? Paano nyo malalaman? Let n be equal to 1. Ganun gagawin. Very good. So that's 2/5 all divided by 1 minus, ano yung ratio this time? 2/5 din, di ba? Tama ba si sir? 2/5 plus 2 times, this time, ang first term ay 3/5. Ang ratio ay 3/5 din. So all you have to do is to, what? Simplify. So maybe we could multiply a 5 on both numerator and denominator para maging ganito. Dito mag-multiply ka ulit ng 5 ulit. So 3 over 1 minus 3. Ay, 5. Sorry. 5 minus 3. Tama ba? Tama ba yung pagkaka... Okay, tama. Tapos magiging 3 times 2/3 plus 2 times 3/2. Oh. Ang sagot ay 2 plus 3 or 5. So the infinite series has a sum equal to 5. So this is a good illustration of, well, the previous theorem and the application of the geometric series formula. Naintindihan niyo yung example na ito? Naintindihan niyo ba? Okay. Move on tayo sa next. O, halimbawa, ito, iibahin natin. Let's say here, I have a variable x. Now, I have the series summation 2 to the n, x plus 3 raised to n. For what values of x is this convergent? At first, it looks confusing, no? But when you come to realize, ito basically, ito expression na ito is basically a geometric series. No? Anong geometric series, sir? Ayun, no? 2 times x plus 3 raised to the power of n. Hindi ba? It's a geometric series with, ang first term na ito ay 1, kasi ang n ay 0 nag-start. Tapos, ang ratio mo ay 2 times x plus 3. So, what do we know about this geometric series? It converges if and only if this converges if and only if The absolute value of r is less than 1. So in other words, dapat yung absolute value ng 2 times x plus 3 is less than 1. So all you have to do is to find out kung anong values ng x ang makakasatisfy dyan. But to say that that has an absolute value less than 1, meaning nasa gitna siya ng negative 1 at 1. Solve natin yung x. Negative 1 half, x plus 3, 1 half, subtract ka ng 3. Negative 1 half minus 3. Ang hirap naman nun. What is this? Negative. Ang hirap. Ano to? Negative 7 halves. Sige, bala kayo, mamamali ako. 1 half plus 3. 7 halves. So the answer, for what values of x is this convergent? The answer is for values between negative 7 halves and 7 halves. Tama ba si sir na yan yung sagot? Okay, okay. So that's the answer. This is an example. Actually, later on, kapag may mga variables na si x, no? May variable na yan. This is a sum of functions now. This is a sum of 1 half. Ayun. Tama kayo dyan. 1 half minus 3. Sabi sa inyo, mamamali ako dito eh. 1 half minus 3 pala. Okay, thank you for the correction. 1 half minus 3 is not 7 halves, but rather, ano yun? Negative 5 halves. Negative 5 halves. Okay, tama na tayo. Okay. Thank you for the correction. So, sa correction, no, hindi siya, ang galing ko, no? Diyan ako magaling talaga. No? Yan ang part na hindi niyo ko aasahan na tama. Okay. Itong klaseng ganitong series, ang tawag dyan later, we will call it a power series. A power series is an example of an infinite series of functions. This time, yung mga terms mo ay polynomials, mga powers of x, kaya nga power series ang tawag sa kanya. Okay? At the end of this lesson, maybe next week, tapos natin yung up to the power series according to the calendar. Sana abutin natin. Okay. Ang una sa mga results natin na meron is the fact that if you have a convergent series, hindi pa pwedeng ang mga terms mo ay malalaki, no? Kasi ang ginagawa natin when you're trying to add a convergent series, we are considering the sequence of partial sums. So kapag yung sequence of partial sums mo, yung dinadagdag mo ng dinadagdag ay lumalaki ng lumalaki o kaya hindi lumiliit, problema yun. Baka yung sequence of partial sums mo, lumaki lang ng lumaki or worse, hindi siya mag-converge at all, no? Tama ba? In fact, as a result, kapag ang infinite series ay convergent, ang unang bagay na masasabi natin is the fact that the nth term of this infinite series must go to 0. Sabihin, dapat yung a sub n lumiliit to 0. Kung nagko-converge man yung infinite series. And that is easy to prove. You know why? Kasi, kunwari, convergent nga sa summation an. So, kunwari, ang sum ay s. Because the sum is s, if s sub n denotes the nth partial sum, you know from the definition that s sub n converges to s. Okay? Sino ba si an? Si an, bakit 0 ang limit nito? Kasi, the truth is, si an, siya lang yung difference nung s sub n tsaka nung s sub n minus 1. Anong sinasabi ni sir? Ganito yan. Ito yung an minus 1, ito yung an. Yung lahat, that's s sub n. Mula dito hanggang n minus 1, that's s sub n minus 1. So if you subtract S sub n minus S sub n minus 1, you will get A sub n as a result. Now, as you can see, si S sub n tsaka si S sub n minus 1, they are not really different sequences. Parehas na sequences ito. Ang nangyayari lang dito sa S sub n minus 1, atrasado lang siya na isang term. Pero kung saan pumupunta yung S sub n, doon naman din siya pumupunta. Nauna lang ito ng isang hakbang palagi. Did you understand? Kaya kung ang limit nito ay S, ito rin ang limit dapat ay S. And therefore, that difference has to be 0. And we can now say that A sub n converges to 0. Kaya nga sabi ko sa inyo, ito yung pinakamadaling theorem natin for today. Okay? Actually, well, that's one way to think about the theorem. But the way I want you to think about the theorem is by looking at its contrapositive. Ayokong tingnan yung theorem ng ganyan. No? But gusto kong tingnan yung contrapositive. Yun yung gusto kong tatandaan ninyo. Ano yung contrapositive niya? Ang contrapositive niyan ay may pangalan. You call it the divergence test. No? Ang sinasabi ng divergence test, kaya kapag ang limit ng isang sequence hindi zero, nako, sure ka dun, yung infinite series mo dapat mag-diverge or wala siyang sum. Naintindihan ninyo, yun yung contrapositive. Kaya lang, hindi ito yung tinawag kong theorem kasi negative yung dating niya is not, tas diverge. No? Parang ang negative mo naman. Charot. Hindi, ibig sabihin, karaniwan ng mga theorems kasi they are stated in a positive tone. Ano yun? Karaniwan pero not always. Right? So, if the limit of a sequence an is not zero, then the sum does not exist. In other words, the infinite series must diverge. For example, when you look at the infinite series, tinakot kayo bigla, no? Nakakita kayo ng summation of the cosine of 1 over n from 1 to infinity. Aba, nakakatakot yan. May cosine na. Hindi ko alam mag-add niyan. Kasi inunahan kayo ng kaba. But when you come to think about this one, no, if you let n approach infinity, yung 1 over n simply will converge to 0. Because the cosine function is continuous, yung cosine of 1 over n will converge to cosine of 0, which is the limit of 1 over n. And you know that the cosine of 0 is 1, and that one is different from 0. So you found out that the nth term of this infinite series has a limit 1 and it's different from 0. So wala nang usapan. Ang sagot, this infinite series, cosine of summation of cosine 1 over n from 1 to infinity must diverge. Naintindihan niyo ba kung paano ina-apply yung divergence test? Okay. So here is my question now. Sabi natin, pag ang infinite series nagko-converge, well, it is necessary that A sub n must converge to 0. No, ang tanong ko naman, yung pag-converge to 0 ba ng A sub n, is that sufficient to conclude that the series is convergent? Or in other words, basta ba ang A sub n nagsi-0 na, convergent na yung infinite series? What do you think? Yung mga terms mo, lumiliit to 0. Kapag inad ko ba sila, lahat hanggang infinity, magiging finite ang sagot? What is your guess? May I know your guess? Anong sa palagay nyo sa sagot na ito? Yes or no? Yes or no question ito. In the chat box, may I know your guess? Yan, may mga sumasagot na. No, no, sa PM no. Well, of course, may experience na kayo sa infinite series kasi, no. Well, ang sagot ay no. Kasi alam niyo kung yes ang sagot, naku, napakaganda ng mundo. Kung ang sagot dyan sa tanong na yan ay yes, napakadali lang pala ng infinite series pag-aralan kasi all you have to do, di ba kung sakaling totoo yan, kailangan mo lang malaman para mag-converge, kailangan yung n term mag-0. That's too good to be true. Di ba? That's too good to be true. Para yung Katniel. Charot. Hindi parang hindi magdududa ka kasi sa math, 'di ba? If something looks easy, 90% of the time that's wrong. Di ba ganun yung sa math? Kung masyadong convenient naman yung nangyari, masyado namang suntok sa buwan, most likely mali yun. Kaya minsan, papakinggan ninyo yung inyong gut feel, no? So the answer is no. In fact, the fact that the answer to this question is no, ang magpapahirap sa theory ng mga infinite series. Ito yung nagpahirap. Ito yung dahilan bakit hindi pala madaling malaman basta-basta kung nagko-converge or hindi. At lalong mas mahirap malaman yung sum, no? Let us see. I have here an example, which is a classic example. We call this as the infinite harmonic series. The harmonic series consists of the terms 1 over n, which are the reciprocals of the positive integers. No? 1, 1/2, 1/3, 1/4, and so on. So that's the term. Those are the terms of this infinite harmonic series. Notice that 1 over n approaches 0 as n approaches infinity. So what's actually happening is that yung ina-add mo at every point ay lumiliit na lumiliit. Diba? Nagdadagdag ka ng 1/2. Nagdadagdag ka ng 1/3. Nagdadagdag ka ng 1/4. Parang imaginein mo, no? Parang kang merong, dinadrawing mo kunwari, ito ay 1. Kunwari, ang area nito ay 1. 1 ang area niyan, kunwari, no? Tapos ito, ang area 1/2. Kasi 1/2 yun. So ito ang area 1/3. Ang dinadagdag mo from at every point ay something na papaliit ng papaliit. Kaya it's hard to believe na hindi ito magko-converge. Kasi the truth is, yung sum ng pag pinagpatong-patong mo yung mga boxes na to, ito mga boxes na drawing ko, no, from the harmonic series. Pag pinagpatong-patong mo sila, you stack them up one on top of the other, makakarating ka ng infinity, makakarating ka ng langit. Mahirap bang paniwalaan yun? Yes, nung una ko nakita ito, I was really amazed kasi how can something na ganyan, no? How can something na mag-a-add ka na mag-a-add ng something ng papaliit ay lalaki ng lalaki ang halaga. Samantalang ang dinadagdag ko from time to time ay lumiliit ng lumiliit. Paano mangyayari yun? That is kind of kaantag dito, counterintuitive. Hindi siya nagma-match the way we feel it to happen, no? Hindi siya parehas doon sa nararamdaman natin yung pandama. Kaya nga, di ba, laging sinasabi sa inyo ni, sino ba yung teacher niya saan? Naging teacher niya ba si Ma'am Rosal? Naging teacher niya si Ma'am Rosal? O di ba, lagi sinasabi ni Ma'am Rosal, mathematics by feelings is not allowed. Kasi sometimes, our feelings are not factual. Sometimes our feelings are just emotions. Kaya, it might not be rational at all. Wala siyang factual reason or wala siyang kaya sometimes hindi ka dapat magtitiwala sa feelings mo. The truth is, pag yun yung sinasabi ni Sir, pag in-stack up mo to from one on top of the other, yung yan, kahit papalitan dinadagdag mo, makakarating yan ng infinity. Magdadiverge siya sa infinity. That's the term. And how do we show that? What I want you to do is I want you to consider these partial sums. The second partial sum is 1 plus 1/2. Okay, hindi na natin i-add. Alam naman natin na 3 halves ang sagot dyan, pero I will not add. Okay? Then I will consider, iskipan ko yung S sub 3. I will consider the fourth partial sum, 1 plus 1/2 plus 1/3 plus 1/4. And then there's something that I am going to do. I will group the last two terms, 1/3 and 1/4. Okay. May tanong ako, between 1/3 and 1/4, sinong mas malaki? Which is bigger, 1/3 or 1/4? Siyempre, 1/3. So, in other words, kapag si 1/3, papalitan ko ng 1/4, will the sum increase or decrease? Anong gagawin ko? Si 1/3, papalitan ko ng 1/4, lalaki ba o liliit yung sum? Ulit. If I'm going to replace 1/3 by 1/4, also, will the sum increase or decrease? Decrease. In fact, anong nangyari dito? Pag pinalitan ko yung 1/3 ng 1/4, magkakaroon akong 1/4 plus 1/4. At pag inad mo yung 1/4 plus 1/4, ano yun? 1/2 yun. Kaya meron ka ng 1 plus dalawang 1/2. Dalawa na yung 1/2 mo. Ito na yun. Okay? Yan yung dalawang 1/2. Now, I'm going to skip S sub 5, S sub 6, S sub 7. I'm going to look at S sub 8. Kasi S sub 8 is interesting. Here, I'm going to do the same logic. No? Ang gagawin ko, papalitan ko yung 1/3 ng 1/4. Tapos yung 1/5, 1/6, 1/7, papalitan ko lahat to ng 1/8. Ang pinapalit ko sa kanila yung pinakamaliit. So in short, the sum will also decrease. But this time, ilang 1/2 na ito? This is 1 plus 1/2 plus 1/2. 1/2 tong dalawa. Itong apat na to, pag 1/8 na yung tatlo, 1/2 din yun. Right? So ilang 1/2 yan? Tatlo. Do you observe a pattern? Do you observe a pattern? This is a very nice pattern. Nakikita niyo yung pattern? Naintindihan niyo si sir? Palagay niyo anong susunod na S ang titignan ko? Anong partial sum yung susunod na titignan ko? S sub? Anong palagay ninyo? Yes, correct. I'm going to look at S sub 16 next. Okay? Susunod, S sub what? 32 plus 64. Basically, I'm looking at the powers of 2. Subscripts which are powers of 2. Okay? Ayan. Kaya meron akong S sub 2 to the K. Imagine niyo, no? Yung subscript mo may superscript. Okay lang yan. Ang sabihin ng S sub 2 to the K, pag kinuha ko na yung pang 2 to the K na partial sum, how many? Kasi di ba ang S sub 8, 2 cube? Di ba ito yung 2 cube? Kaya meron kang tatlong 1/2. Yung 4 ay 2 squared, meron kang dalawang 1/2. Kaya kapag nasa 2 to the K ka na, ilang 1/2 na? K. Kaya 1 plus K over 2 yung lower bound. Okay? Now, what do we know about 1 plus K over 2 pag lumalaki yung K? Let's say, let's keep getting K as large as we want. Ano mangyayari dito? Yung 1 plus K over 2, ano yun eh? Linear function yan on K. Ang slope ay 1/2. So in short, papalaki lang ng papalaki yung 1 plus K over 2 without bound. So as you can see, si S sub 2 to the K ay nagda-diverge sa infinity as K approaches infinity. And yet, yung S sub n natin is strictly increasing kasi nga nagdagdag ka na nagdadagdag ng term. If a subsequence of it diverges to infinity tapos nag-i-increase ka as a sequence, anong mangyayari sa S sub n? Ay, magda-diverge din siya sa infinity. Di ba? Kasi yung subsequence mo, nagda-diverge sa infinity. Tapos, increasing. Hinahatak ka nung pagiging increasing. Sasama ka lang sa pag-diverge sa infinity. Kaya all in all, si S sub n ay magda-diverge sa infinity. Kaya we will say that this infinite series diverges to positive infinity. Ang ibig sabihin ng diverges to positive infinity, hindi ka nakarating ng infinity, ha? Ang ibig sabihin nun, ang limit ay infinity, but not because ang limit ay infinity, it doesn't mean na nagko-converge. Ang converge, ginagamit lang natin kapag ang limit ay isang real number. Ang infinity is more like just a notation, no? That something grows without bound, no? That's diverging to infinity. Yun yung meaning ko nung diverges to infinity. But sometimes you can see some authors or some mathematicians would write this way, na sinusulat na equal sa infinity. Kasi nga ang limit mo ay infinity. Although that doesn't imply convergence, still that implies divergence. Okay? So this is an example or a counterexample to the converse of the divergence test, no? Sabihin, imaginein mo ito nagsisiro naman yung mga terms, pero no? Alam niyo yung dahilan? You know what happened? No? Ito yung nangyari. Yan, plinat ko sa inyo yung, imagine niyo i-stretch niyo yung 1. Ito yung 1 unit, 1 unit, 1 unit. Pero dito sa y-axis, stretch niyo si 1. Actually, square ito eh, no? Hindi lang siya mukhang square. Kasi nakabanat siya sa y-axis. Okay? Ang area nito 1, ito 1 half, ito 1/3, 1/4. Kita nyo, papaliit naman ang papaliit, pero yeah, ang sum ng mga pink rectangles na yan, ano, infinite, right? Infinite pa rin. Yeah, that's the sad truth. The reason is, you know what's the reason? Although this is going down to 0, no? The truth is, it is not going down fast enough. Yung pagbaba niya sa 0 ay hindi masyadong mabilis. In fact, mabagal siyang, nababagalan pa pala tayo sa 1/n eh, no? Kasi tignan nyo, i-compare nyo siya sa infinite geometric series na ito. Tignan nyo, no? I have here a comparison. Here is an infinite geometric series with ratio 1/2 and starting at 1. Ito yung 1 plus 1/2 plus 1/4 plus 1/8 and so on. Ito yung unang example ko sa slide na ito. Naalala niyo yung mga squares, pinagdugtong-dugtong ko. Diba? Naalala niyo ba to? Nasaan ba yun? Ito, naalala niyo to? Yung 1, 1/2, 1/4, 1/8, 1/16, 1/32. Eventually, anong sum niyan? 2. Kasi parang sinishada natin yung dalawang squares. Okay? So going back, ngayon mako-confirm nyo na that the sum is actually 2. No? You just apply the geometric series formula. The sum will be 2. That's 1 minus 1 minus 1/2. Right? If you compare these two sums, no, what do you notice? The geometric series goes down to 0 quite faster than the harmonic series. Although ito yung nagsisiro rin, pero in a slower pace or in a slower manner than the geometric series. No? Naintindihan niyo ba yung pinagsasabi ko? Ang tanong dito, anong critical na question dito? Ano yung question na dapat mag-pop sa isip ninyo? Ang dapat na tanong dito, gaano ba kabilis dapat sir bumaba para ma-consider na convergent yung sum? Yeah. Kung bababa sa 0, how fast should I go down to 0? What should be my speed? No? Gaano ba kabilis dapat bumaba sa 0 para masabing nag-co-converge? Fortunately, may sagot tayo dyan. And I will present the answer later. Na kung gaano ba kabilis ang pagbaba sa 0 para mag-converge. Later, we will have an answer. So here is another question. Can we know the convergence of a series without having to know the sum? Yes, actually. Paano natin malalaman? Well, we make use of Cauchy sequences. Naalala niyo yung Cauchy sequence of real numbers? Pag sinabing Cauchy, two terms are close when their subscripts are large. Yun yung ibig sabihin natin ng Cauchy sequences. Two terms of the sequence will be close whenever their subscripts are two large integers. In other words, as the subscripts gets larger and larger, the terms are getting closer and closer to one another. You remember that ang pinagkaiba ng definition ng Cauchy sequence sa definition ng convergent sequence, sa definition ng Cauchy sequence, walang binabanggit na limit. Kasi yung original definition ng convergence, kailangan alam mo yung limit beforehand to guarantee the convergence. But according to this theorem from advanced calculus, no, a sequence of real numbers is convergent if and only if it is a Cauchy sequence. In other words, this Cauchy property is already enough to guarantee you convergence. Yun nga lang, it doesn't mean na malalaman mo yung limit. We can guarantee the convergence without having to know the limit. Now, in terms of infinite series, saan natin dapat i-apply yung Cauchy property para mag-converge? Di ba dun sa sequence of partial sums? So if we now look at the sequence of partial sums of this infinite series, magko-converge ito if and only if this is convergent. And that will converge if and only the sequence of partial sums is a Cauchy sequence. Now, anong ibig sabihin ang sequence of partial sums ay Cauchy sequence? Ito siya. This is what we call as the Cauchy's criterion for convergence pero of infinite series. Bakit naging ganito yung itsura? Tingnan natin, ha? So, the infinite series summation an of real numbers converges if and only if for every epsilon greater than 0, an integer n can be exhibited to exist so that this finite sum an plus 1, an plus 2 up to am has an absolute value less than epsilon whenever m is greater than n and little n is at least capital N. Anong nangyari dito? Yung ito kasi, when you come to think of it, kasi si m ay higit sa n, no? So pag ililista mo yung mga terms, a sub 1 plus a sub 2 hanggang a sub n, dahil nga mas malaki si m, pwede mo pang ipagpatuloy itong n. You can keep on continuing. Tapos, hanggang marating mo yung a sub m. Eventually, may hit mo yung a sub m. Yung terms na ito, yun yung s sub m. Correct? Kaya, tapos itong mula dito hanggang doon, yun yung s sub n. So, when you subtract s sub m minus s sub m, ito siya. So, may absolute value. So, yung expression na nakikita nyo yan, in-apply yung Cauchy property on S sub n. Okay? Did you understand? Ito yan, no? In-apply ko yung epsilon property and Cauchy property na ito doon sa sequence of partial sums. Naintindihan ninyo? That's why there's no need to prove. Kapag na-prove nyo yung na ito'y totoo, for every epsilon greater than 0, then you can guarantee that the infinite series is convergent without having to know what the sum is. Okay? Now, another thing to recall. Naalala niyo yung monotone convergence theorem when you were a little younger sa advanced calculus. I hope that you can still remember this. Ang sabi nito, if you have an increasing sequence of real numbers and your increasing sequence is bounded above, sabihin hindi siya lalaki ng lalaki kasi may upper bound. Ito yung upper bound mo. Diba? Upper bound, let's say u. Anong conclusion? The sequence has to converge. So, tandaan nyo na, if the sequence of real numbers is increasing, and you found out that it has an upper bound, then it must be convergent. Correct? Naalala nyo to? You remember this? Meron tong kakambal. Ano yung kakambal niyang result? Kapag naman ikaw ay nagde-decrease, pero may lower bound ka, mapipilitan ka rin mag-converge. Because there is no other there's no other thing to do. Kasi bumababa ka tapos may lower bound ka. Pababa ka ng bababa tapos may lower bound ka, ay mapipilitan ka mag-converge. You call this is the monotone convergence theorem or MCT. This is why if we consider an infinite series where each term is non-negative, no? Paano pag lahat ng terms mo non-negative? Ano mangyayari sa infinite series mo? Pag lahat ng terms ng infinite series mo non-negative, bawal ang negative, no? Positive or zero lang ang pwede. Ang masasabi natin sa S sub n in that case, kasi ang dinadagdag mo ng dinadagdag ay laging positive or zero, yung sequence of partial sums mo ay isang increasing sequence. Naintindihan ninyo? To give the proof, kapag sinubtract mo S sub n plus 1 minus S sub n, ang maiiwanan A sub n plus 1. Yung A sub n plus 1 na yan, non-negative nga. So in short, itong difference na to na negative, ilagay mo sa kanan yung S sub n, ito yung lalabas. So in short, the sequence of partial sum is an increasing sequence. O ngayon, increasing sequence na yung sequence of partial sums kung non-negative ang mga terms. Ang tanong, kailan siya magko-converge? May sagot na kayo nandoon sa itaas. Ang kailangan na lang natin malaman or ma-prove ay dapat yung sequence of partial sums mo ay bounded above. Ulit, kapag ang infinite series ay may non-negative terms, ang convergence ng summation an ay matutukoy if and only if yung sequence of partial sums ay may upper bound. And by that we mean there exists a number b such that this quantity, itong quantity na to actually that's S sub n, di ba? S sub n is less than or equal to b for all n. Kahit na anong partial sum ang kunin mo, hindi siya lumalagpas sa b. If you can find a number b such as this, then convergence can be guaranteed. So as you can see, no, kapag non-negative ang mga terms ng infinite series mo, mas madaling matukoy ang convergence. Sometimes ang magpapagulo sa convergence ng isang infinite series ay yung kapag may negative na terms. Kasi pag may negative na terms, yung sequence of partial sums mo bumabalik na imbis na mag-proceed lang siya sa kanan, bumabalik siya kapag may mga negative na terms. Kung wala namang negative na terms, the S sub n will keep on going to the right. No? Will keep on going to the right. So kung meron kang upper bound, may harang sa kanan, increasing ka, sabi ng MCT, S sub n has to converge. Did you understand this result? And why is this true? This is a consequence. Kumbaga, ito ay restatement lang ng monotone convergence theorem. Yung nakaraan naman, ito naman, restatement ito ng Cauchy's criterion for convergence. Okay? Yan. Sinasabi nga natin, the conclusion does not hold when the series has negative terms. Kasi halimbawa, ito. Di ba? Kasi kapag titignan mo yung S sub n nito, ang S sub n nito dalawa lang. 0 or 1. Di ba? 1 if n is odd. Negative 1 if n, sorry, 0 pala if n is even. Di ba? Kung mapapansin nyo, yung sequence na ito ay bounded above. 1, 0, 1, 0, 1, 0. It's bounded above. In fact, an upper bound could be 2. Pero hindi natin pa pwedeng sabihin, no, hindi natin pa pwedeng sabihin na itong series na ito ay nagko-converge. Kasi first of all, hindi nag-a-apply yung previous theorem kasi yung series na ito ay may negative na term. So nag-a-apply lamang itong theorem na ito only for series with non-negative terms. Kaya nga magpa-follow na kapag ang infinite series ay may non-negative terms, dalawa lang ang pwedeng mangyari. Okay. Diba, series with non-negative terms. Anong pwedeng mangyari? Dalawa lang ang pwedeng mangyari. Okay. Ang case 1 mag-converge. Okay. Case 2 mag-diverge. Pero, pag nag-diverge, paano siya magda-diverge? Kasi kung ang sequence of partial sums mo ay increasing, the only way for an increasing sequence to diverge is to diverge to positive infinity. Kaya tatandaan nyo, pag ang series mo may non-negative terms, dalawa lang ang pwedeng mangyari. Either mag-converge siya to a finite number or mag-diverge to positive infinity. Hindi mangyayari yung nakaraan. Kasi itong series na to, nag-diverge pero hindi sa positive infinity. It simply diverges kasi walang limit. Pero hindi papunta sa infinity yung sequence of partial sums. Did you understand? In other words, mas simpleng i-analyze ang mga sequence, ang mga series with non-negative terms. Kaya nga, Ang sa ating susunod na gagawin, so ito yung infinite series natin, no? Yung pag-aaral natin ng infinite series. Hahatiin natin to sa dalawang part. Part 1, if your infinite series has non-negative terms. Okay? Kasi ito yung mga masayang part. Medyo madaling i-analyze yung mga series with non-negative terms. Part 2, ito yung medyo mahirap pag-aralan. Ito yung with negative terms. Ano ba yung mga alternating series? Nandito yan. Kasi palit-palit ng sign, yung mga ganyan. Pag-aaralan natin. So, hahatiin natin yung ating pag-aaral into 2 parts. Okay? And these are the 2 parts. Mag-start tayo sa part 1 right now. No? Paano kapag ang series may non-negative terms? How can we determine its convergence? Isa pa rin naman ang tanong natin up until now. Paano malalaman kung nagko-converge or nagda-diverge ang isang infinite series? It turns out na meron tayong mga tests na pwedeng i-perform, no? Pag dito sa dito sa unang part, no? Meron tayong mga tests na pwedeng i-perform to guarantee convergence or divergence, no? And these are ilan ba yung i-discuss ko? Magdi-discuss ako ng limang test. I bet narinig nyo na yung mga pangalan ng mga ito before kasi I think naging topic nyo na sa analysis 3 ito before, no? Ito yung tinatawag na integral test. We will begin with the integral test. Gagamit tayo ng integrals to test convergence. We have the comparison test. We have the limit comparison test. We have the ratio test. And the n-truth test. Lahat ito i-represent ko sa inyo ngayon. Sabay-sabay na. Kasi, ano lang naman ito, kumbaga nadaanan nyo na ito before, ang ngayon lang, kailangan makita nyo yung idea bakit gumagana yung mga tests na ito. And what do they say? No? We will start with the integral test right now. And this is the integral test. Mami, ipapakita ko sa inyo kung paano ito ginagamit. But for now, let's first read the theorem. So here, you get a function f whose domain is the interval from 1 to infinity including 1. So nag-start siya sa 1, pakanan. Okay? This function has the following properties. It has 4 properties. Number 1, it's positive, meaning to say it never goes down to the x-axis. It never goes below the x-axis and on the x-axis. Pangalawa, it must be continuous, just like in the picture. Do you see that? Pangatlo, it must be decreasing. No? Pababa. Pangatlo, hindi lang siya basta decreasing. Kailangan siya ay nag-approach 0 as x approaches infinity, just like in the picture, no? As x approaches infinity, si f of x ay lumiliit na lumiliit to 0. Nagde-decrease, positive, and continuous. So, make sure nyo na yung 4 na criteria na ito ay nasa-satisfy before you can apply the integral test. Okay? Alright. So, for each n, i-define ko yung sequence na a sub n as follows. I will let a sub n to be f of n. Halimbawa, ano yung f of 1? Ito yung f of 1. Okay? Yung height niyan yung f of 1. Ito yung f of 2. Ito yung f of 3. Ito yung f of 4. Ito yung f of 5. Ito yung f of 6. Como 1 unit ang laktaw-laktaw na ito, pag multiply ko to with this, or in other words, if I consider the area of this rectangle, yun yung f of 1. Gets nyo? Gets nyo ba na yan yung f of 1? Ito yung f of 1. Ito yung f of 2. Ito yung f of 3, yung area ng mga yan, and so on. Naintindihan ninyo? O hindi, mas madali yatang tawagin A1, A2, A3, A4, A5. Okay? Ang formula sa AN is that ang AN ay F of N. Okay, do you agree? Okay. We have the following test. If and only if kasi ito yun. Matindi to, if and only if. Ano yung sabihin ng if and only if? Pag nag-hold yung isa, mag-hold yung isa. Pag false yung isa, false yung isa. Ano yung dalawang statements? This infinite series of blue rectangles converges if and only if this improper integral converges. Sabihin yung improper integral na to ay nag-exist. Now, by the way, you're going to integrate f of x from 1 to infinity. Now, just to recall and just to remind you kung paano ginagawa yung mga integrals like this, yung infinity doon, ang gagawin nyo, papalitan nyo muna ng isang dummy na variable, let's say t, and then evaluate mo muna ito. And then after evaluating, tsaka mo ngayon kukunin yung limit as t approaches infinity. Yun yung sabihin yan. Kailangan yung limit na ito yung nag-e-exist. Or in other words, the integral, the improper integral must also converge. Okay? Furthermore, ang tanong dito ngayon, sir, sinasabi mo ba na yung value ng integral na to ay parehas doon sa infinite sum, or sa series, sa sum ng infinite series? Are you saying that they are the same? No. I am only saying, ano yung sinasabi ni sir? I am only saying na kapag yung isa ay finite, yung isa rin ay finite. Kung ano mas madaling computein sa'yo dyan, malaman mo, for example, ito finite ang value. O di therefore, convergent ito. O kaya, mas madaling na-discover mo, ito ay convergent. O di dapat ito finite ang value. May sinabi ba si sir na parehas ang values nila? Wala. Okay? Wala akong sinabi kasi take note, tingnan nyo. Ang integral na ito, in my picture, is the area under the red curve. No, equal ba siya dyan sa blue? Hindi, di ba? Hindi, di ba? In fact, nandito yung ating estimate kung ano yung difference ng dalawa. In fact, sinasabi nito na yung infinite series is always bigger than the value of the integral. In fact, yung infinite sum mo minus the integral, hindi pa pwedeng lalagpas sa A1 yung upper bound. Ibig sabihin, kung ano man yung area nito, at most, ganyan kalaki yung difference sila. Hindi pa pwedeng mas malaki dyan. Kung may difference man sila. Pero sabi ko kasi nyo, 99% of the time, hindi equal yan. Hindi yan equal sa 0. It could be 0. It could be there. They could be equal. Hindi natin inaalis yung pagkakataon na yon. But what I'm saying is that 99% of the time, these two are not the same. Kaya wag nyo sasabihin na, ay, ito integral, finite siya, ang value ay 39, kunwari. Therefore, the sum is 39. That's wrong. Okay? Be warned, no? Warning. In general, the value of this integral is not the same as the value of this infinite series. Kasi si A sub n siya yung f of n. Baka isipin nyo na pareha sila. They are not necessarily the same. Okay. So how can we make sense of the integral test? Okay. So here is the proof. Buti na lang meron akong tinype dito pala. So let k be an integer greater than 1. Okay. Now what I want you to look at is the interval from k minus 1 up to k. Wala, ano yan? Ano yan? Ano ginagawa ni sir? Pag ganyan na, nakakatakot na eh. Dahan-dahan, tignan niyo yung picture. O imagine niyo ito si F, nasa kth na interval na ako, no? Ito yung kth na interval. Titignan niyo yung k minus 1 hanggang k. O, yan yun, di ba? Alright. Kapag kumuha ko ng x, nasa ni x? If I take an x anywhere between here. Anywhere between k minus 1 and k, if I take an x, anong masasabi nyo sa tatlong numbers na to? Ito yung f of k minus 1, ito yung f of x, ito yung f of k. Because the function f is decreasing, sinong pinakamalaki? Ang pinakamalaki yung f of k minus 1. No? Pinakamaliit ay yung f of k. Kung ano man yung x mo dyan sa gitna, nandito yung x eh. It's right here, no? Kung ano man yung x na yan, sige nga, drawingan ko nga to ng pula. Di ba, pag drawing yung tatlong vertical lines na yan, ang pinakamalaki palagi ay si f of k minus 1, pinakamaliit ay si f of k, nasa gitna palagi si f of x. O ngayon, by definition, sino ba si f of k? Si f of k, siya si a sub k. F of k minus 1, that's ak minus 1. The reason for this is the fact that f as a function is a decreasing function. Kasundan yan, yung unang hampas ng bagyo. Okay, let's continue. Anong gagawin ni Sir next? Ang gagawin ko, I will integrate from k minus 1 to k. Ano yung sabihin nun? Oh my gosh. Ano nangyari? Ganito yung nangyari dyan. I-integrate ko from k minus 1 to k yung ak dx. So, syempre, yung integral na yan, hindi lalagpas sa integral ng f of x dx. At hindi yan lalagpas sa integral ng ak minus 1 dx. Now, take note that ak and ak minus 1 are only constants. Pag constant, paano nag-i-integrate? Paano tayo nag-i-integrate pag constant? Lalabas lang yan tapos dx, di ba? So, lalabas ak tas k minus 1. Ganyan siya. Gawin yung integral. Kasi ito, lalabas yung ak minus 1, integral ngayon ng dx, di ba? So, x from k minus 1 to k. So, ganyan ulit. It turns out na ito ay 1. 1 lang to. Diba? Ano mangyayari? Aha. Mangyayari ito. Yung integral ng f of x mo from k minus 1 to k is somewhere between a sub k and a sub k minus 1. Paano siya i-imaginein sa picture? Ganito yun. The truth is, ito yung a sub k talaga. Diba? Ayan yung a sub k. Ito yung a sub k minus 1. Alright. So, yung integral ng f of x from k minus 1 to k, siya yung area na ito. Okay, siya yung area na yan. Right? The truth is, kung a sub k ito, 1 unit ito. Pag minultiply mo yan together, you will get the area of this rectangle. So, yung area ng mas maliit na rectangle is what? AK. Yung area ng matangkad na rectangle, that's AK plus 1. Kaya yung area under the curve is between or is squeezed between the area of the smaller rectangle or the shorter rectangle and the area of the bigger rectangle. Nasusundan nyo yung picture at saka ito? Kung paano ini-interpret to in pictures, ito? Nasundan nyo? I-integrate mo. So, yung mga values na naging area na ngayon yan. Kanina, sa unang sentence, mga straight lines lang silang ganyan. Pag in-integrate mo, yung mga stick na yan, nagiging area na siya lang. Diba? Pag in-integrate mo ito siya area ng rectangle. Pag in-integrate mo tong kaliwa, itong lalabas. Pag in-integrate mo to, itong lalabas. Okay? Anong gagawin ko ngayon? Ang gagawin ngayon ni Sir, kukunin ko yung sum ng mga yan, k from 2 to n. Oh my gosh. Ano nangyari? Summing up k from 2 to n, so parang ina-add ko yung a sub k from 2 to n. Sige nga, pahabain natin to. A sub 2, A sub 3, hanggang A sub n. Kung mapapansin nyo, kulang lang to ng isang term para maging, ano, S sub n. Di ba? Anong kulang sa kanya? Ang kulang sa kanya ay A sub 1. Kaya this is actually S sub n minus A sub 1. Naintindihan ninyo? Parang kulang ka lang ng isang term. Paano bang gagawin ko? Yan. A sub 1 plus A sub 2, A sub 3, A sub n minus A sub 1. Therefore, this is S sub n minus A sub 1. Ayun, yun yung left-hand side. Okay? Yung right-hand side muna tayo. Yung right-hand side, pag inad mo ay k from 2 to n, anong mangyayari? If you add ak from 2 to n, you will get ak minus 1 pala ang ina-add dito. A1 plus A2 hanggang an minus 1. Sino naman to? Malalabas naman dyan yun yung S sub n minus 1. Kaya meron kang S sub n minus 1 sa kanan. Okay? Okay. Ano naman mangyayari pag yung integrals na to inad ko k from 2 to n? Oh my gosh. Ano mangyayari? O di, start tayo sa umpisa. When k is 2, integral to from 1 to 2. Di ba? When k is 3, integral to from 2 to 3. When k is 4, integral to from 3 to 4. Yung f. And so on. When k is n, integral ito from n minus 1 to n nung f. Di ba may properties ang integral? Pag in-integrate mo from 1 to 2, inad mo yung integral from 2 to 3, inad mo integral from 3 to 4, it's just a single integral. Integral lang yan lahat-lahat from 1 up to yung dulong-dulo, which is f. Kaya ako nagkaroon ng ganon sa gitna. Maraming nangyari dyan, no? Sina-shortcut ko lang sa slides. Pero these are the computations that are involved. Were you able to follow? Nakasunod ba tayo? May tanong kayo before I proceed with the next step? Wala? Yung iba, may I know the, how about the others? Okay, none so far. Very okay. So, from this inequality tayo magpapatuloy. Na? Ito yan. Ito na. Diba if and only if yung ipoprove natin, ano yung theorem? The sum converges if and only if the integral converges. Ito na. If the sum converges to S, anong mangyayari? If you let n approach infinity, anong mangyayari dito sa S sub n? Magko-converge sa S. Okay? Anong mangyayari dito sa S sub n minus 1? Magko-converge din yun sa S. Atrasado lang siya ng isang term. At pag yung n nagpunta ng infinity, ano mangyayari sa integral na to? Magiging integral from 1 to infinity. O ngayon, ito na. Nagko-converge nga kasi ito kaya si S ay finite. Kaya kung si S ay finite na number, mas maliit tong integral, therefore, the integral exists. Did you understand? So, na-prove natin na kapag yung infinite series ay nagko-converge to some number S, yung integral mo ay mag-exist kasi hinaharangan siya ng S sa kanan. On the other hand, if the integral, ito na yung pabalik, kapag yung integral naman ay nag-exist, kunwari ang value niya ay, anong mangyayari? Gagamitin ko ulit yung inequality na to, ginamit ko yung ito, in particular, ito siya. Ito yung integral from 1 to infinity. E positive yung function. How does it compare from the integral from 1 to n? Parang ganito to eh. Okay, so drawing ko sa inyo. Ito yung function. Okay. Yung integral from 1 to n, ay yung dilaw na ito. Ito yung 1 up to n. Okay? Ano yung integral from 1 to infinity? Yung 1 to infinity, lahat-lahat yan. Mula umpisa hanggang sa dulo ng walang hanggan. Sinong mas malaki? Siyempre, yung integral from 1 to n ay mas maliit doon sa value ng I, which is finite. I is finite, correct? So, titignan nyo yung inequality na to. Ignore nyo na yung integral doon sa gitna. Yung S sub n ngayon, isa-solve mo, yung A sub 1 lagay mo sa kanan. So, ano nangyari? Aha! Si S sub n ay less than or equal to A sub 1 plus I. These are just finite numbers. You can call it M. So, si S sub n ay bounded above by some finite number M. Anong sabi ng monotone convergence theorem? Si S sub n ay increasing and is bounded above. So, therefore, ano si S sub n? Sagot. Ulit, si S sub n ay increasing, tas may upper bound siya na M. Ano siya? Convergent. So, therefore, kung yung sequence S sub n mo convergent, ano yung infinite series? Convergent. And we are done. Di ba? After all, yun lang, ganun lang ka-ikli yung proof. Medyo marami lang computation but it's not really hard. No, paano natin ipoprove yung furthermore? Merong furthermore, ini-estimate yung difference ng integral na to tsaka nung summation na to. Dito ka manggagaling. Kasi if you let n approach infinity, ano mangyayari dyan sa inequality na yan? At magiging s minus a1. Ito yung integral mo from 1 to infinity. Tapos ito yung s ulit. Okay? So if you subtract an s, ano bang gagawin niyo, sir? Mag-subtract kayo ng s on both sides. Okay, so that's what happens if I subtract an s. Tapos, mag-times ka ng negative 1 on both sides. Pag nag-times ako ng negative 1, yung 0 mapupunta sa unahan. Ito magkakabaligtad. At yung nasa kanan mo ay A1. Ayan na yung furthermore natin, di ba? It was really just obtained from this inequality by letting n approach infinity. Did you understand? Did you understand this? Ayan. Naintindihan ninyo yung proof ng integral test. Okay, sige. Dahil tayo 4:30 na, no? So we will take a short break. Pahinga muna kayo, inom kayo, or ihi kayo for 10 minutes. I will pause the recording now. Okay. So let's now talk about the following infinite series. Ayan na, no? This time nakakita na kayo ng ln something. Kaloka, no? May mga ganun na. So, obviously, kung gagamitin yung definition, napakaliit ng chances na kayo yung mag-succeed, no? Sa pagde-determine ng convergence or divergence ng mga sumusunod na infinite series. Kasi, even when you consider the sequence of partial sums, it's kind of hard to judge, no, by the looks of it. No. Dahil ang previous theorem ay integral test, no, so in these examples, tuturuan ko kayong gumamit ng integral test at kung paano siya gamitin, right? So here, so number 1, ang a sub n natin ay ln n over n squared. Okay? Ang tanong dito, paano nyo malalaman kung ano yung f of x? May f of x dito sa integral test. Ano ba yun? Di ba? Paano nyo malalaman kung sino yung f of x? Ito yung relationship. I-define mo si f to be a function so that ang f of n ay nag-agree sa a sub n. So how do you do that? Where's my slide? So essentially, you will just let f be ln of x all over x squared. No? Anong meron dito sa ln of x over x squared? This is positive. Continuous. Decreasing. On 0, 1. On 1 to infinity. And ang limit ay 0. You can check that the limit is 0 by applying L'Hopital's rule. No? L'Hopital's rule lang yan. Ang limit ay 0. So yung mga conditions na meron tayo doon sa theorem or sa integral test, you can just check this one by one. Okay? Now the limit is 0 can be obtained by L'Hopital's rule. Okay? Alright. Now, ang gagawin nyo ngayon, diba? From here, makikita niyo yung a sub n is simply f of n. So we now apply the integral test by integrating the given function from 1 to infinity. Now, I'm going to integrate f from 1 to infinity. Ano ba yung f natin? Hindi ko na patatagalin. Ganyan na lang. Paano ba ini-integrate to? Oh my gosh, hindi na ako marunong. Any suggestion on how to do this? Well, eto muna yan, di ba? Ay, sorry. First of all, ito'y limit as t approaches infinity ng integral from 1 to t. ln of x all over x squared dx. So, paano natin gagawin ito? How should we integrate this one? So, let me copy this. Copy. Mag-scratch tayo para hindi makain yung ano. So, meron tayong ln of x over x squared. So, how do we integrate this? Any substitution that you know that can help you? Integration by parts? Okay, yeah, maybe. Kasi tignan nyo, wait. If I let u be ln of x, no? Then, ang du natin, paano nga ba to? Nakalimutan ko na. Sorry ha. Hindi ako nakapag-prepare. Hindi ko nahanda yung sarili ko na mag-integrate ako. Tama ba to? Tama ba si sir? So, yung integral na ito ay may isang x na may iwanan sa baba. 'Di ba? May x ka dito, kakaroon ko ng u, kasi hindi x over x. Oh, teka lang. ln of x, ganyan siya, 'di ba? So, magiging u du, pero meron ka ditong x. Anong gagawin mo sa x? Okay, alam ko na. From this equation, you can solve for x. Ang x mo dyan ay e to the u. So, meron ka ditong u over e to the u du, or basically, u e to the minus u. So, mukhang tama nga si Aubrey, no? Mukhang ano to, hindi ko kasi alam basahin yung pangalan mong isa. Si Aubrey na lang. Mukhang tama nga siya na tayo ay mag-integration by parts kasi na-reduce ko sa ganito yan, no? Tapos, paano nga integration by parts? Ganito. Yung polynomial na u, i-differentiate ko ng i-differentiate hanggang maging 0. I-integrate ko naman ng i-integrate yung minus yun. Naturuan ba kayo ng ganitong method? Yung plus minus. Kaya ang sagot, minus u e to the minus u minus e to the u. E to the minus u plus c. Integration by parts ang tawag dyan. Pero syempre, ibabalik natin yan doon sa original na integral. Oh my God, napakahirap naman pala nito. Oh my gosh. Okay. Ano bang minus u? Minus u is minus ln of x. Ang e to the minus u is 1 over x. Di ba? Ang e to the minus u ay 1 over x. Reciprocal siya ng x. So, paano natin ibabalik sa dati? E to the minus u is 1 over x. So, this is minus ln x over x. Ganyan. Tapos, e to the u is 1 over x. E to the minus is 1 over x plus c. Did I get it correctly? Paki-check nga yung aking mali ako. Ginagamit ko ito mga to ha. Ito. To replace everything. Same tayo ng sagot? Okay. So, very good. So, maybe, tama na ito talaga. Okay. So, ano bang ini-integrate natin? 1 to infinity. So, we're doing it from 1 to infinity. Ay, 1 to t muna pala. Okay. Paano natin siya gagawin 1 to t? What? X squared 1 to t. Pag yan ay 1 to t, let me just copy this one. Copy. Paste. Like that. Tapos, x is from 1 to t. When x is t, this is just minus ln of t over t minus 1 over t. Tapos, when x is 1, that's ln of 1 over 1. ln of 1 is 0. Yan. So, we're left with, oh my gosh, what's this? O, di ganyan, no? Minus 1 plus ln of t all over t. Tapos may plus 1. Okay? Alright. Yeah. And now, for the final part, yung 1 to infinity, check mo ito. Kukunin mo yung limit nito as t approaches infinity. Sana mag-0 to. Sana mag-0 to. Diyos ko, day. Sige, tingnan natin. Mukhang magsisiro naman ito. Applyan nyo lang ng L'Hopital's rule. Ito kasi infinity over infinity to. So, apply nyo ng L'Hopital's rule. Yung numerator magiging negative 1 over t. Yung denominator magiging 1. So, L'Hopital's rule talaga naman pala. 0 plus 1. So, the limit is 1. As you can see, the integral is finite and it has a value of 1. But again, that doesn't say that ito ay may value na 1 and that's finite. Okay? Therefore, anong sagot? Ito ay convergent. Ibig sabihin ba nung 1, yung sum na ito ay equal sa 1? Hindi naman. No? Hindi natin masasabi yon. Alright? How about for number 2? Ano naman yung f of x na i-consider nyo dito? Papalitan nyo lang yung n ng x. Basically, ganyan siya. You can check that this is again positive, continuous, decreasing, and the limit is 0. So, ang an natin dito is again f of n. Okay? So, integrate natin from 1 to infinity yung dx over x ln of x. Alright, this time parang hindi naman mahirap alamin ito, no? Kasi parang yung integral niya malalaman natin kagad. Ang gagawin mong u dito, ln of x, tapos ang du mo, dx over x. So parang meron kang du over u. So parang ln of u ito. So parang ln of x. x from 1 to infinity. Ang ibig sabihin ng infinity, ililimit mo siya as x approaches infinity, but that's just infinity. When x is 1, 0 yan. Di ba? Tama ba? Tama ba ako? Yeah. So the thing is, ito yung infinity. Kahit na ano yung number na yun, infinity na yan. So therefore, because the integral is infinite, what does that mean for the infinite series? This infinite series is divergent. Okay? So ganun lang siya kasimple. Pero hindi siya simpleng gawin, ha? I mean, the conclusions that we can derive from the integral test is very simple. Sasabihin niya kung convergent or divergent. Pero in practice, hindi siya madaling gawin kasi you have to do integration. Na kung merong magandang dinulot, yung integral test ay yung sumusunod. Right. So let P be any number greater than 0. In analysis, this series that you see in the board, no? Itong series na ito, pag in-expand ko ito, kanya yung itsura niyan, 1 to the P, 2 to the P, 1 over 3 to the P, so on. This is what we call as a P series in analysis. Sikat na sikat ito. Sikat na sikat yung series na yan, and I will show you, I will tell you later why. Okay? This is what we call as a P series, where P is a positive number. Okay? Obvious naman ba siya tinawag na P kasi may exponent na P yung mga ano. So, halimbawa, when P is 1, you have the harmonic. Diba? The harmonic series is an example of a P series where P is 1. So, we will prove that this P series will converge if and only if P is greater than 1. So, how would we know that? First of all, if P is 1, harmonic siya, divergent na. Huwag na natin tignan yung case when P is 1. So, assume na natin that P is not 1 para wala na tayong problema. Okay? May conclusion na tayo, divergent. Anong gagawin natin dito? For this, we will consider the function f of x equals 1 over x to the P, or basically x to the minus P. Again, you can check that this is positive, decreasing, continuous, and its limit is 0 as x approaches infinity. So the conditions for the integral test are met. Kailangan titignan nyo muna yun isa-isa. Right? And then we are going to integrate this from 1 to infinity. So you get something like this, or something like this. Ano ba nag-integrate ng ganyan when P is not 1? Kasi kapag ang P ay 1, ln yan. When P is 1, yung integral na to ln. Eh, hindi na nga 1 yung P. Kaya ito'y power formula lang. Diba? So, mangyari, x to the 1 minus P over 1 minus P. Nag-add ako ng 1. Nag-add ako ng 1. Ito yung plus 1 plus 1. X to infinity. Okay. Anong mangyayari dito? Oh my gosh. So, kailan ito magko-converge? Well, yung x, palalakihin natin ng palalakihin to infinity. So, sa x yung gumagalaw. So, titignan nyo na lang yung x raised to 1 over p. So, parang ang tanong dito na lang, when is the limit of x raised to 1 minus p as x approaches infinity finite? Yan na lang ang tanong. No? Kailan nagiging finite yan? Halimbawa, anong limit ng x squared as x approaches infinity? Diba infinity? Diba? In fact, basta positive ang exponent, kahit na let's say square root of x, infinite pa rin yan. In fact, basta positive ang exponent, infinite ang limit. Pero pag ang exponent ay negative, just like this, ano ba, x raised to negative 2. Ay, this time 0 siya. Diba? Tama? Um, yeah. Kapag limit ng x raised to negative 1 half even, 0 yan kasi 1 over square root of x tas ang x ang lumalaki, no? So, anong conclusion? Kailan nagiging finite ang limit na ito? Anong dapat na exponent? Sagot, ano? Kailangan yung exponent ay ano dapat yung exponent? Dapat yung exponent ay negative. Correct. At pag negative yung 1 minus p, anong value ng p? That's equivalent to saying that p is greater than 1. Therefore, ito yung magko-converge if and only if p is greater than 1. You don't need to compute, no? Kasi wala ka naman mapapala dun sa value, eh. You just need to know kailan siya finite, kailan siya hindi, no? Pero kung gusto nyo, kung interesado kayo sa value, sige na nga. So, in fact, if p is greater than 1, anong value neto? Magiging 0 lang pala yan when x is infinite, di ba? 0 lang siya when x is infinite. But when x is 1, that's what? 1 over 1 minus p. Kaya ang value is 1 over p minus 1, which is finite. Okay, may sinasabi ba yung 1 over p minus 1? Wala naman. Kaya nga hindi ko na ginagawa eh. Di ba? Wala naman tayong information na makukuha dun sa 1 over p minus 1. Ang mahalaga is the fact that alam natin na ito yung magiging finite whenever p is greater than 1. Kaya yung infinite series na ito ay magiging convergent only when p is greater than 1. Naintindihan ninyo? Halimbawa, I will give you an example. Sabihin niya kung convergent or divergent, ha. Halimbawa, ito. Let's say I have 1 over the square root of n summation. Is this convergent or divergent? Divergent. But divergent. Ang p mo ay 1/2 kasi. That's not greater than 1. Halimbawa, summation n from 1 to infinity, 1 over the square root n square root of n. Convergent or divergent? Convergent or divergent? Okay, mas marami ang convergent. Doon may mga sumagot na divergent. The answer is convergent. Ang p mo dito ay 3 halves. Paano naging 3 halves? Kasi yung n square root of n, ganyan siya. Okay? And 3 halves is already greater than 1. Ang maganda dito, no, imagine niyo, halimbawa, I have something like 1 over n raised to 1.000000001 kahit na gaano kadami yung 0. No? Ito'y convergent. No? Pero, kapag yan ay saktong 1, of course, that's divergent because that's the harmonic series. Imagine niyo, no? Konting lagpas lang doon sa exponent, kahit na gaano kaliit, it's already convergent. Pero pag 1 talaga, divergent talaga yan. Naintindihan niyo? This is what we call as the p-series test. Kung p-series lang naman yung mga series ninyo. Ang condition para mag-converge, dapat ang p ay greater than 1. May question ba tungkol sa p-series? Ano yung sinasabi ko? Bakit importante ito sa mathematics. Ay, importante yan kasi sa mathematics, when P is greater than 1, well, we know that this converges. But the truth is, alam ba natin yung sum? We don't know. No? In fact, we define for P greater than 1, the function zeta of P to be the sum. Kung ano man yung value nito, kung ano man yung sum na yan, yun yung zeta of P. This zeta in mathematics is what we call as the Riemann zeta function. Okay? Yung Riemann zeta function na yan ay valid lang, yung formula na yan ay valid for P greater than 1 at kapag si P ay real number. Okay? Si Riemann, may isang mathematician, si Riemann niya ang pangalan. Ang ginawa niya, ito yung real number line, saan lang valid mula 1, sa kanan ng 1, no? Ang ginawa ni Riemann, inalam niya yung mga values niyan, for example, na natutunan niya ang zeta of 2, kapag ito'y n squared. Alam niyo ba na ang value nito ay pi squared over 6? Imagine niyo, no? Paano nagkaroon ng pi, paano nagkaroon ng 6 dyan sa sum? Well, gumamit ng Fourier series, no, to determine the exact value of this. But of course, we will not do it here. You might study it someday, but not here. Ano ba, ang zeta of 4, natutunan na Riemann. Kung di ako nagkakamali, sana tama ito. Ito'y pi to 4 over 96. If I'm not mistaken, ba't may mga pi? Ba't may mga ganun? Oh, anyway, those are some of the values of the zeta function. So Riemann, ang ginawa niya, may mga properties yung zeta function na na-derive siya, no? Tapos, na-discover niya yung connection ng Riemann zeta function sa mga prime numbers. Kaya yan P, eh. No? Riemann discovered the connection between the prime numbers and the Riemann zeta function. Ang ginawa ni mahirap ipaliwanag, eh, no? Mahirap siya ipaliwanag, sa totoo lang. Ang ginawa ni Riemann, in-extend niya yung definition nito even to complex numbers. Ibig sabihin, kapag si P ay complex numbers, ito pa rin ang definition niya. Basta ang P ay may real part na greater than 1. Ibig sabihin nun, kung ito yung complex plane, basta yung complex number mo nandito sa kanan ng 1, may value na ibubuga yung zeta of P. No? And then, using complex analysis, or ano ba tawag doon? Yeah, complex analysis. Riemann was able to extend the definition of the Riemann zeta function to the entire complex plane maliban sa isang number. Na-extend niya dito sa lahat, sa buong plane, maliban dun sa 1. Ang tawag dun sa 1, that's a singularity of the Riemann zeta function. Wala talagang value yung Riemann zeta function. Ang tawag dito sa paraan na ginawa niya yung analytic continuation. Ano man ang ibig sabihin nun, no? And then Riemann was interested with the zeros of the Riemann zeta function. Ang isip ng zeros, saan dito sa complex plane, no, saan dito, sa banda ng complex plane, nagsi-zero yung value ng zeta of P. No? Napansin niya na merong mga ilang zeros dito sa negative real axis. May mga zeros dito sa negative real axis. Right? For example, zero siya, kapag negative 2, kapag even, negative whatever, ganito. Dito tas natutunan niya, gamit yung analytic continuation niya, na ang value niya at negative 1, no, is negative 1 over 12. Dito nang galing yung palaging meme na negative 1 over 12 sa mathematics. If you can see memes in the internet and talking about negative 1 over 12, na dito nang galing yun, yung yung Riemann zeta function na yan, nung in-extend ni Riemann yung definition sa buong complex plane, nalaman niya ang value sa -1 ay -1/12. Ang nangyari, yung mga memers, now ginamit yung definition na ito, pinalitan yung P ng -1, tapos in-equate to sa -1/12 when it's not really the same. Now, it's not really the same. Kasi yung definition na ito, nag-hold lang dito sa portion ng plane na ito. Pag nasa kaliwa ka ng line na ito, iba na ang definition niya para maging analytic or kung ano man yung ibig sabihin ni Riemann ng word na yon. Kaya yung mean, sabi ni Riemann, yung zeta of -1 is -1/12. Pag you falsely use this formula, let's say ginamit na yung formula na to to evaluate zeta of -1, ang mangyayari ganyan. Kaya nagkaroon ng mean na nagkaroon tayo ng mean na 1 plus 2 plus 3 plus 4 plus blah 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 equals -1/12. Kung nagbabasa kayo ng mga meme sa internet, you might find that this is a ginagawang meme ng mga mathematicians, whatever. May mga mathematicians sa internet na sira ulo, di ba? But of course, it's not true kasi ang definition ng Riemann zeta sa kaliwa ng line ay iba na. Very complicated and I'm not going to talk about that. Na maliban sa mga some points dito na interesting, hindi natin alam kung nasan pa yung ibang zeros ng Riemann zeta function. But according to Riemann, kung magkakaroon man ng zeros yung Riemann zeta function na yan, matatagpuan mo yung zeros na yan dito sa vertical line na ito. This is the critical line na tinatawag sa 1/2. X is 1/2. Pag na-prove mo na yung mga zeros ng Riemann zeta function ay nandito sa line na ito, anywhere, somewhere there. Pag na-prove mo na ito yung kailangan mo ma-prove, kapag ang zeta of z is 0 implies the real part of z is 1/2, ibig sabihin yan, nandito siya sa vertical line na ito. Pag na-prove mo ito, meron kang $1 million. But $1 million? Kasi isa to sa mga sa 7 of isa to one of the 7 millennium prize problems in mathematics. Kapag na-prove mo na nag-zero yung Riemann zeta function only on this critical line, no? Dito siya nag-zero, meron kang $1 million as a prize. And maliban nun, malamang sisikat ka sa mathematical community. Or maybe in the entire world. Kasi this problem has been open for hundreds of years already. Ba't natin gusto malaman yan? Kasi nga, pag nalaman mo yan, approve mo yan, it will imply a lot of things about prime numbers. Malalaman natin how the prime numbers are scattered in the real number line somehow. Matutuklasan natin kung paano nakakalat yung distribution ng mga primes na tinatawag sa real number line. Ano yung impact nun? Kasi alam nyo, yung mga, for example, sa computer science, may tinatawag na cryptography. The way we encrypt data, no, in computers, for example, when you try to input passwords. Alam nyo kung paano pinaprocess ng computer yung password ninyo? Sa palagay ninyo, alam ng computer yung password ninyo? Ano ba, pag nag-type ka, nag-pin ka ng password sa ATM, no? Time yung password mo. Nalalaman ng ATM na tama yung in-input mong password or mali. So, ibig sabihin ba nun, alam ng computer yung password mo? The truth is, hindi. Paano nyo na-verify? Ayan. Ang computers natin, kapag pag nag-encrypt siya ng data, gumagamit yan ng dalawang malaking prime numbers. Kumukuha yan ng dalawang malaking prime numbers. Tapos minumultiply niya yun. Aanihin mo naman yun. Pag kasi nag-multiply ka ng dalawang malaking prime numbers, mahihirapan kang i-factor yun pabalik. Halimbawa, sinabi ko may malaking number akong pinakita sa inyo. Sinabi ko, ay product yan ng dalawang malaking prime numbers. Hanapin mo ngayon dalawang primes. Madali bang gawin yon? Di ba hindi? Especially when the number of digits is large. Yung kahirapan na yun ng pagfa-factor, ang ginagamit ng ating mga computer scientists sa pag-hide ng mga maseselang information sa internet. Na yung tinatawag na RSA public key cryptography na tinatawag. Gumagamit ng mga prime numbers. Kaya kapag naintindihan natin paano nagbe-behave yung mga primes, somehow may improve natin yung mga security systems and etc. Kaya yung mga problems na ito, they are worth millions of dollars kasi hindi lang yan dahil meron siyang mathematical value but yeah, meron siyang impact sa buong mundo kapag na-solve natin yung mga problems na yan. Ang tawag sa problem na yan ay yung called this the Riemann hypothesis. It's one of the Millennium Prize problems in mathematics. We don't know if this is true or not. Wala tayong proof or wala tayong disproof na hindi siya totoo. Okay? Nag-start siya dito sa P-series, no? Yun yung kanyang history. Nabanggit ko lang naman. Okay. So what are we going to do with the series that we already know to converge, no? Kapag meron ka ng listahan ng mga series na alam mo nagko-converge, you can make use of them or you can utilize them to prove that other series are convergent or divergent as well. Magagamit mo sila para matest kung how about this series? Iko-compare ko siya sa alam kong series na nagko-converge. Ito yung tinatawag nating comparison test. Now, what is the comparison test? It's stated as follows. Let's say you get two sequences AN and BN. So that they are both non-negative. Di ba lahat ng series natin dito kasi non-negative? Di ba? Non-negative lahat ng series. Pangalawa, dapat dinodominate ni BN si AN for N greater than or equal to K for some K. Anong ibig sabihin yan? Ang ibig sabihin ko niyan, ito-dominate ni BN si AN eventually. Hindi ko sinasabing for all N kasi hindi naman required na for all N. Okay? Ang ibig sabihin ko niyan, kung ito yung Cartesian plane ninyo, ito yung N-axis, 1, 2, 3, 4, 5, 6. Let's say ang K ay 4. Narit yung K. Ang sinasabi ni Sir, maaring sa umpisa, ito kunwari AN, maaring sa umpisa, hindi mo masabi yung behavior ng AN tsaka ng BN, no? Halimbawa, ito kunwari sa AN, okay? So, kunwari kukulayin ko ng blue si BN, maaring sa umpisa, yung dalawang yan, well, hindi mo malaman yung behavior nilang dalawa. Ang importante, dapat pag dumating na yung point na K, dumating na yung time na yun, dapat si BN palagi nang nasa ibabaw ni AN at never nang iilalim. Did you understand? Sa umpisa, we don't care how they behave. Basta ang importante sa atin, after some time, dinodominate na ni BN si AN. Did you understand my explanation about that phrase? Okay. Hindi mahalaga kung anong ginagawa ng dalawa sa umpisa. Kahit magbaligtaran sila, we don't care. Ang importante sa atin, darating yung time na dapat dinodominate na ni BN si AN. Okay. Ano yung comparison test na sinasabi natin? Number 1. Kung yung sum ng mga nagdo-dominate ay nagko-converge, no? Kung yung sum ng mga nagdo-dominate ay nagko-converge, edi lalo na yung mga mas maliliit, lalo na hindi na-dominate. Kasi yung sum nga ng mga mas malalaki, finite eh. Di lalo ka na. Naintindihan ninyo? Kasi yung AN mas maliit sa BN eventually eh. So kung yung sum ng mga BN ay finite, dapat ganun din yung sum ng mga AN. Did you understand? Ginagamit natin tong comparison test sa mga jokes actually. Kapag tayo nagjo-joke sa mga magkakaibigan. Diba may kaibigan kang yayamanin, di ba? O kaya may kaibigan kang matalino, laging mataas sa test. Tapos sasabihin niya, wala akong nasagot sa test. Sasabihin na isa, ikaw nga walang nasagot, di ako pa. Di ba? Ang tawag doon comparison test in action. It's like the same idea. Naintindihan niyo? Kumbaga dito, mas malaki yung value ng B sub n. Diba? Malaking value ng B sub n. Tapos yung sum ng mga B sub n na yan, naging finite. Dahil mas maliliit yung mga kay A sub n, no? Dapat yung sum ng mga A sub n, finite din. O kaya, sabi ng kaibigan mo, sabi ng kaibigan mong sosyal, ay wala na akong pera. O, di ba yung ganon? Uy, ikaw po, wala ng pera. Kung wala kang pera, ano pa ako? Ganon. Yung tawag doon, comparison test. Number 2. Ano sabi naman ng number 2? Kung yung sum ng mga mas maliliit, ng mga dinodominate, ay infinity. No? Nakarating ng infinity yung sum ng mga mas maliliit. Ano mag-follow? Naturalmente, yung sum lalo ng mga mas malalaki ay makakarating lalo sa infinity. Mas malalaki yun eh. In fact, kung papansinin niyo yung dalawang statements na ito, they are actually one statement only. Statement number 2 is actually the contrapositive of statement number 1. Did you notice that? Napansin niyo ba na yung statement number 2 ay contrapositive lang ng statement number 1? Yes or no? Did you notice that? Ano yung sabihin natin ng contrapositive? Ito, isabihin natin ng contrapositive just in case you did not know. P then Q yung statement, ang contrapositive ay not Q then not P. Sa logic kasi, ang P then Q, equivalent lang siya sa not Q then not P. Walang pinagkaiba ang lohika ng dalawang yan. In short, pag na-prove natin yung isa, na-prove mo na yung dalawa. Parang ano yan, buy one, get one. Did you understand? Parang buy one, get one ito. Pag na-prove mo yung isa, na-prove mo na rin yung other one. Kaya gagawin natin sa proof yung number 1 lang. Because proving number 1 also means proving number 2. Okay. So we will only prove statement number 1, just like what I'm saying. No? So we will assume, in this proof, we will assume that the sum of the bigger ones or the dominating ones is finite. In other words, the infinite series is convergent. Okay? Now, we will prove that the sum of the ANs, the smaller ones, is finite. So, ang gagamitin ko, ba't may let epsilon greater than 0 na kagad na doon na? Palagay niyo anong gagamitin ko? Ang gagamitin ko ay yung Cauchy's criterion. Tama ba? Actually, pwedeng gamitin ko na yung monotone convergence theorem eh. Pero, sige, Cauchy's criterion. Let's see kung ano yung sinasabi ni sir. So, sa Cauchy's criterion may epsilon eh. So, you start the proof with let epsilon be greater than 0. Like what I have always told you, ang proofs analysis, 90% of the time will begin with let epsilon be greater than 0. Ayan na. I-apply natin yung Cauchy's criterion para doon sa summation ni B. Ano bang sabi ng Cauchy's criterion? Sabi ng Cauchy's criterion, may some natural number m. Pag may epsilon, merong isang natural number na m, so that if you have two integers exceeding m, sabihin na lang natin mas malaki si m. Okay? Yung s sub m minus s sub n ay may absolute value na less than epsilon. Yan yun. Eh yung S sub M minus S sub N, kapag nilista mo kung ano yung mga terms na nakapaloob dyan sa difference na yan, ito yan. Ito yung matitira kapag binawas mo yung first N terms from the first M terms. Okay? Kasi ang M ay greater than N. Okay? Ang M, yung mama mo, mas mataas sa nanay. Yung M ay mas malaki sa N. Mama greater than nanay. Kasi yung tunog ng M at N, baka nalilito kayo. Okay? Because of this. Now, tingnan natin ngayon yung mga terms ng AN. Naku, ano na naman to? Kasi tingnan nyo. Meron tayong inequality dito sa taas. But I cannot say that this is true for all N. Kailan lang to totoo? Totoo lang to paglagpas ng K. Di ba? Ito naman, nagkakatotoo paglagpas na nung dalawang subscript na yon sa M. Ang tanong, kailan sabay magkakatotoo yung dalawa? Because I want them to be true at the same time. Ano ba, paglagpas ng alas 10, ito paglagpas pa ng alas 12, kailan sila magsasabay na true? Ang sagot, paglagpas ng alas 12. Kaya kinukuha palagi natin whichever is larger between these integers so that pag may dalawa kang integers na lagpas na ng kung sino man yung mas malaki, parehas ng true yung dalawang inequalities na to. Anong mangyayari? This is what will happen. If I take the S sub M minus S sub N for the series summation AN, ito yun eh. Diba? Ito yun. Lahat naman yan ng negative eh. Don't worry. You can take out the absolute value, sign. Ito mangyayari. Okay? Because of this relation, this is already happening kasi ang N na natin lagpas na ng K. Diba? Diba? Kasi nagpas na siya ng N eh. Yung N kung ano mas malaki sa dalawa. Ito, less than or equal to Bn plus 1 na. Ito, less than or equal to Bn plus 2. Yung AM, nagpas na yan, mas maliit yan sa B sub M. Ano ba sabi dito sa taas? Whenever this is true, this is less than epsilon. True na rin naman ito kasi nga, ito ay true. At ang N yung mas malaki doon sa dalawa. Kaya true ito, therefore true ito, kaya ito ay less than epsilon. In the end, ito yung na-prove, for every epsilon greater than 0, there exists an N, capital N, so that if two integers M and N both exceed N, this absolute value is less than epsilon. Yan yung Cauchy's criterion for the summation of AN. And what does it prove? It proves that summation of AN is also convergent. And for that, we are done. Nakuha nyo? Okay. So, in practice, medyo mahirap i-apply ang ang comparison test. Hindi kagaya ng integral test na medyo straightforward. Ang comparison test ay it will take a while para masanay kayo. That's why you have to practice. You have to open books in calculus and try to practice. Right? So, halimbawa ito. Ano ipapractice? Kailangan, first of all, dapat meron kang library ng mga convergent at divergent series. Kasi, ba't may library, may listahan ka? Diba yung umpisa nga ng lecture natin, lagi akong nagbigay ng maraming example ng convergent, maraming example ng divergent. Kaya dapat may library ka, kasi dun ka magko-compare. Dun mo i-compare yung mga series na ibibigay sa'yo. Naintindihan ninyo? Halimbawa, if your intention is to prove that this is convergent, maghahanap ka ng mas malaki na ang sum ay magko-converge. Kung ang intention mo is to prove that this is divergent, maghahanap ka ng mas maliit na ang sum ay magda-diverge. Ganon ang comparison test. That's why most of the students are getting a hard time in doing comparison test kasi this is really hard to do. I'm not sugarcoating anything. No, this is really hard to do in practice, especially kung first time. I will show you, for example, sa number 1. What do you think is this? Kailangan ito may pandama ka muna eh. Kailangan may pandama ka kung convergent or divergent. What do you think about this? Is this convergent or divergent? Wala kayong nararamdaman dito? Wala eh, no? Hindi ko alam kung ito yung part na I cannot I'm getting a hard time sharing this to my students, yung pakiramdam. Kasi ako minsan sometimes tinitignan ko pa lang parang nararamdaman ko kung ano yung mangyayari in the end. I cannot I don't know how to share that skill to my student. Maybe just maybe ito yung product ng ilang years ng pagbabasa, no? Ilang years ng pagsosolve ng mga problem. That's why sabi nga nila ang mathematics ay talaga namang practice. You have to keep on doing it. Hindi pa pwedeng spectator ka lang na nanonood ka lang sa ginagawa ng teacher. Dapat you are actually doing it. You are actually writing it by hand para ma-experience mo. Okay. So, sa aking palagay, ito'y convergent. Yung number 1. How did I know? Ganito. Turuan ko kaya ha. Turuan ko kayo ng pandama. O sige, pandama. Ganito ko nararamdaman. Yung n plus 2, iniisip ko linear lang yan. Iniisip ko n lang siya. Okay? Bakit n lang? Ang truth is, kapag lumalaki na yung n, may papel pa ba na ginagampanan yung 2 sa n plus 2? Diba? Compared to n, when n is large, yung 2 hindi na yung nagmamatter. Halimbawa, meron kang 1 bilyong piso at 2. Papansin mo ba yung 2 pesos? Diba? Kapag nagbibilang kayo ng kayamanan, papansin mo ba yung 2 pesos sa kayamanan? Diba it's irrelevant already when you are at that level? Naintindihan mo yung sinasabi ko. Bakit yung n plus 2 iniisip ko lang na n? Naisip niya? Okay. Sige. How about yung n cubed plus 3n? Yung n cubed plus 3n, well, pag lumalaki yung n, actually, yung n cubed dito is overpowering. When you say overpowering, imagine mo n is 1 million. Compare mo nga yung 1 million cube sa 3 times 1 million. May halaga pa ba yung 3 million mo pag pero ka ng 1 million cube? Di ba? Wala na. I mean, hindi na siya nakaka-apekto sa significant growth ng function. You get what I mean to say? That's why this is ang term na ginagamit sa analysis, asymptotic to n cube. Hindi ko sinasabing approximate ha, kasi ibang approximate. Parang tanggalan mo man ako ng 3 million basta meron akong 1 million cube. Okay na ako dun. Papamigay ko na yung 3 million. Parang ganun yung idea. This is why, kapag nakita ko yung n plus 2 divided by n cubed plus 3n, ang iniisip ko lang, 1 over n squared. Nagets nyo? Nagets nyo? Okay. Kung 1 over n squared yan, ano nga yung sum ng mga 1 over n squared? Convergent ba to or divergent? Convergent or divergent? Convergent. Alam nyo, convergent ito. Galing, no? Ganun lang pala yun. Oo. Yan yung technique. Ganun lang siya. So, parang ito, parang sa aking paningin, ito yung 1 over n squared lang. Kaya, kung magko-converge or magda-diverge yung 1 over n squared ang magdidikta. Kaya ang gagawin ko ganito. Dahil alam ko na parang 1 over n squared siya, i-compare ko ito sa 1 over n squared. Ang tanong, paano ko siya i-compare? Pakanan or pakaliwa? Or should I use less than or equal or greater than or equal? Depende. Because summation of 1 over n squared is convergent, I need to go to the right. Kasi I need to show that something bigger has a finite sum. To conclude that this sum is finite as well. That's the comparison test. Naintindihan nyo? So, dapat pakanan tayo. So, paano magagawa yun? Ganito. Ito yung skills na tinatawag ko. Ganito ha. Yung ano. Oh my gosh. Ano ba yung ginagawa ko? Parang bigla ako nag-blackout. Okay. Anyway, n cube plus 3n. Anong gagawin? If n is large, kaya na lang yung English, no? If n is large, how large is large? Anyway, an n cube plus 3n, pag ito'y binura mo, pag binura mo yung 3n, kasi gusto ko mabura yung 3n, di ba? Anong mangyayari sa n cube plus 3n? Lalaki or liliit? Kahit 3 milyon ang tanggalin mo, liliit pa rin. Di ba? Tama ba? Tama ba? Tama ba inequality? So, yung 1 over n cube plus 3n, ano mangyayari dyan? It's less than 1 over n cube. Yan. Okay, malapit na. Malapit na matupad yung pangarap ko. Now, how about n plus 2? Ang gusto ko mawala yung 2. Pero I want to do it ng pakanan kasi numerator tayo eh. So, anong i-add ko sa 2? Di ba ang n plus 2, mas maliit yan sa n plus n kung si n ay large na? Tama? So, this is basically, this is basically equal to 2n. Kaya, kapag i-combine ko yung dalawang inequalities na ito, tsaka ito, anong makukuha ko? Therefore, yung n plus 2 over n cubed plus 3n is less than 2n over n cubed. Yeah, and that is 2 over n squared. Burahin ko na yung pandama. Okay? Since summation of 1 over n squared is convergent for n large. Lagyan dito for large n. Parang hindi na natin kailangang specify. Since summation of 1 over n squared is convergent, then you can say that the summation of 2 over n squared is convergent as well. Nag-multiply lang ako ng 2. Di ba property yan? So, by comparison, kung yung sum ng mga mas malalaki ay finite, lalo na yung sum ng mga mas maliliit. Dapat yung sum na ito, yung which is yung given na sum, must be convergent. Okay? And that completes the proof. Okay? Nasundan nyo? Ito yung sinasabi ko, mahirap to sa umpisa kasi para kang nag-freestyle. Walang step by step. Kung ang hinahanap yung step by step method, hindi yun uso dito sa subject na yon. Actually, maraming nagpe-PM sa akin. Ang tanong palagi, so paano nyo nalaman na ganito yung gagawin? The true answer is I don't know. Nararamdaman ko lang. Kaya nga, sinasabi ko that this is one skill that you have to learn by watching someone do it first, no? So that when the time comes na kayo na ang gagawa, dapat familiar na kaya. This is one skill that you have to develop, yung tinatawag na intuition. Ang math kasi hindi lang siya yung puro, akala nyo pag nagsusulat ng proof sa math, dire-diretso lang sinusulat yun. Hindi. It takes a lot of intuition to be able to come up with these things. How about the second one? First of all, notice that n starts at 2, no? Kasi kapag ang n ay 1, ang ln of n ay 0. Kaya ina-avoid natin yung 1 kapag ang n ay, kapag ang expression natin may, pag ang denominator may ln, ina-avoid natin yung n equals 1. Pero that's not really important. Remember, kapag limits, ang mahalaga, malaking values ni n. Hindi mahalaga yung umpisa, ang mahalaga ay yung wakas. Okay. So, what do you feel? What do you feel? What do you think about this series? Is this convergent or divergent? Bigla nagkaroon ng LN eh. No? Paano nyo gagamitin ngayon yung tinuro ko sa inyo? Okay, bigyan ko kayo idea. Sige, pandama. Drawing yung axis. Alam niyo yung ln of x, yung graph nun, di ba pag ganito? Whereas yung y equals x, so sino ang mas nagdo-dominate? Si x o si ln of x? Yung growth ni x ay mas mabilis kaysa sa growth ng ln of x. In fact, yung growth ng ln of x bumabagal ng bumabagal habang tumatagal ng tumatagal. So when it is being compared to x, iniiwanan siya ng x. Yung ln of x nagpapaiwan siya mag-isa. Kumbaga, si y equals x yung si y equals ln of x ang ang tawag na ito? O basta, ayoko na nga magsalita. Huwag natin magpa-time na. 5:46 na pala. My gosh, nagulat ako. Nandito pa lang tayo. Slide 23 out of 44. Oh my God. So anyway, basta si x ay dinodominate si ln of n. So we can say that if n is large, yung n ay mas malaki sa ln of n. This is a comparison that is used a lot of times. Okay? Tatandaan nyo to. So, when compared to 1 over n, which one is larger? Ang 1 over ln ay mas malaki sa 1 over n palagi. Correct? Tama ba? Correct? Kapag nagre-reciprocal yung inequality mo, bumabaligtad ha. Kung mga positive sila. Kailangan positive sila. I-write ko to. Okay. Anong alam natin tungkol sa sum ng mga 1 over n? Divergent or convergent? Divergent. Correct. So, yung sum ng mga mas maliliit, divergent. So ano? Yung sum ng mga mas malalaki, must also diverge. Since this is divergent, then magka-follow by comparison, sum ng mga 1 over ln of n must also diverge. Must diverge. O diverges. Okay? May S kasi singular yung sum. Okay? So divergent yung number 2. How about the third example? Oh my gosh. What's this? But may n factorial dyan. Is this convergent or divergent? Anong dama nyo dyan? Ako ang pandama ko, converge. Kung ako tatanungin nyo nang wala akong kaalam-alam, ang isasagot ko converge. Alam nyo bakit? Itataya ko yung natitira kong dangal. Pag ito'y nag-diverge. Ito'y converge. Alam nyo bakit? Bakit itataya ko ang dangal ko dito? Wala akong kaalam-alam. Kunwari, pinanganak akong bobo. Tinanong ako, convergent ba to? Divergent. Ang taya ko, convergent. Alam niyo bakit? Kasi yung n factorial, mabilis lumaki. Di ba? Halimbawa, kapag ang n mo 10 na, ang 10 factorial is already millions, di ba? Napakabilis niyan lumaki. N factorial grows astronomically. Consequently, if you take the reciprocal, mabilis lumiit. It decays fast enough that the sum of the 1 over n factorial becomes finite. No? Mabilis na mabilis lumiit yung 1 over n factorial, kaya yung sum niyan, madaling paniwalaan na finite. Naintindihan nyo? Ang tanong, kanino natin siya i-compare? One of the things that ang naisip ko, papasok sa isip ko dyan, mga ano, yung mga tawag dito, exponential. Halimbawa, i-compare ko siya sa 2 to the n. Kasi ang 2 to the n is fast to grow, pero mas mabilis ang n factor. Alam niyo bakit? Tingnan niyo ha. When n is 1, 2, 3, 4, 5, 6, 7. Okay, compute natin. Ang n factorial, anong 1 factorial? 1, di ba? Ang 2 to the 1, 2. Aha, may head start yung 2 to the n, di ba? When n is 2, this is 2 factorial, that's 2. 2 to the n is 4. Aha, humaharurot yung 2 to the n. Di ba? When n is 3, this is 6. And this is 8. Ayan, ako, medyo nagigising na yung n factorial. Kasi from 1 to, biglang naging 6, apat kagad yung tinalon, no? Kinabahan niya yung si 2 to the n. Yun naman pala, ang 4 factorial kasi ay 24, ang 2 to the 4th ay 16. Ayan na, naungusan na siya ni n factorial. Parang imagine mo nagre-racing yung dalawa, no? And when n is 5, 120. Palagay nyo may pag-asa pa tong 2 to the n? May pag-asa pa ba yung 2 to the n? Humabol. Meron pa? Hindi ko na alam yung susunod. Huwag nyo nang pa-compute. Wala na, no? Kailan nagsimulang humabol yung n factorial? 4. Ito yung sinasabi ko kanina, yung k. Diba? So in this case, ang 2 to the n ay mas maliit sa n factorial. In fact, strictly, no? When n is greater than or equal to 4. Ito yung big K kanina doon sa theorem. Hindi mahalaga kung anong nangyayari sa umpisa. Ang mahalaga ay yung mangyayari in the end. Right? Yun yung sinasabi ni Sir. Hindi. Kasi maaring sa umpisa, nagbabagal-bagalan, nagpapanggap, parang kumbaga sabi ni n factorial, o sige, papartida ka na. Papartida na. O sige, nabagalan ko muna. Ikaw mo una. Parang ganon. O tapos nung full force niya na, no? After 4 seconds, kunwari seconds yan, wala na talagang di na makakahabol yung 2 to the n. No, bakit ko naisip to? Kasi, if you take the reciprocal, 1 over n factorial, mas maliit ngayon to sa 1 over 2 to the n. Ang 1 over 2 to the n ay 1/2 raised to n. Oh, that's familiar, di ba? Okay? What do I know about the sum of 1/2 raised to n? This is convergent. Why? Why is this convergent? Anong reason? Anong reason? Ba't convergent yan? Pag in-expand nyo to 1/2 plus 1/2 squared plus 1/2 cubed. Ayan, geometric with R equals 1/2. Less than 1 ang absolute value. Okay? Yun yung reason. So that is convergent. Hence, by comparison, anong masasabi natin? By comparison, yung sum ng mga mas maliliit, convergent din. Tamad ako maglagay ng is. Lagay na lang natin converges. Okay? Therefore, the sum of the 1 over n factorials is convergent. Sige, may papaisip ako sa inyo. Isipin nyo sa bahay ito. let P sub n be the sequence of prime numbers. Alam mo yung prime numbers, no? So, pag nilista mo yung sequence na ito yung lalabas. 2, 3, 5, 7, 11, what else? 13, 17 ba susunod? 19, etc. Yan siya, no? Okay, ito yung P1, P2, P3, and so on. Question, converge or diverge? I-add mo yung reciprocal ng mga prime numbers, okay? You try looking at the sum of the reciprocals of the prime numbers in the increasing order. Yung 1, magiging 1/2 plus 1/3 plus 1/5 plus 1/7 plus 1/11 plus 1/13, 1/7, ganon. Isipin nyo sa bahay kung ito yung nagko-converge or nagda-diverge. Tapos tatanungin ko kayo next time kung anong sagot ninyo, ha? Anong palagay nyo? Sige, isipin nyo sa bahay ito and then try to make some justification kung kaya nyong i-justify yung sagot ninyo. Pero kung hindi, di hulaan nyo na lang. Basta tatanungin ko kayo next time kung ito yung nagko-converge or nag-diverge. Siguro we will stop from here and yeah, we will just continue next time.